All right, let's take a look at the practice test. We're told to find the complement of each angle. For the first problem here, we're given an angle that's 1 degree. And remember that complementary angles are two positive angles with a sum of 90 degrees. So in other words, if I took 1 degree and I added its complement, I should get 90 degrees. So basically all I have to do is say 90 degrees minus this angle here, which is 1 degree. That's going to give me 89 degrees, so that's going to be the complement, okay? So you could just write it here, or you could write it out. I'll just say that it's 89 degrees here, and you could write out a sentence and say the complement of this 1 degree angle is 89 degrees, but I'll just box this off and say this is our answer. Okay, for problem 2, we now have 35 degrees, and again, all I'm going to do is take my 90 degree angle, which is the sum of two complementary angles, and subtract away this angle here, which is 35 degrees, and that is going to give me 55 degrees. So again, you can use a little sentence if you want, or you can just box this off and say it's 55 degrees. That's going to be the complement of this 35 degree angle. Okay, for the next two, we want to find the supplement of each angle. Now, I want you to remember that supplementary angles are two positive angles with a sum of 180 degrees. So if we think about this one for 3, we have 117 degrees. So all you would do is take 180 degrees, that's the sum, and you're going to subtract away this known angle, which is 117 degrees. If you punch that into your calculator, you're going to get 63 degrees. So again, I'll just write 63 degrees. I'll just erase this and I'll box this off. So these two angles right here would be supplementary angles. Again, they're two positive angles, and the sum is going to be 180 degrees. Okay, let's look at 4. So here we have 88 degrees. Again, I'm just going to start with 180 degrees, and I'm going to subtract away this 88 degrees, punch that into the calculator, and I'm going to get 92 degrees. Okay, so that's going to be the supplement, and let me just write that here. So 92 degrees like this, and I'll just box it off. Okay, the next thing we're asked to do is to determine whether the given angle is acute, which means it's greater than 0 degrees, but less than 90 degrees. Right, which means it's exactly 90 degrees. Obtuse, which means it's greater than 90 degrees, but less than 180 degrees. Or straight, which is 180 degrees exactly. So for problem 5, we have a 68 degree angle. And so this guy is going to be an acute angle. So this is an acute angle. And again, an acute angle is where the angle is greater than 0 degrees and less than 90 degrees. So the 68 degree angle falls into that category. For problem 6, now we have an angle that's 144 degrees. And this guy is going to be an obtuse angle. So this is obtuse. And again, that's going to be greater than 90 degrees, but less than 180 degrees. So that's how you know you fall into that category. All right, now for the next two, we'll have a little bit of algebra. We want to find the measure of the complementary angles. So here for problem 7, you have 2x plus 13 degrees and 20x plus 11 degrees. So there's 2 steps if you get a problem like this. The first part is basically realizing that, again, complementary angles are going to sum to 90 degrees. So you're going to say that 2x plus 13, forget about the degree symbol for right now, we don't need it, then plus this 20x plus 11. If I sum those two together, it should be 90. Once you solve this, you're not done. You have to actually go back and plug in. So I'll show you that in a moment. So we're going to just say that 2x plus 20x is 22x. And then 13 plus 11 is going to be 24. And this is equal to 90. Let's subtract 24 away from each side of the equation. This cancels. We'll say 22x is equal to 90 minus 24 is going to be 66. We'll divide both sides of the equation by 22. Let's cancel this with this and say that our x here is going to be 66 over 22 is 3. All right, so we know that x is 3. So that's the first part. Let's come back and say that x is equal to 3. But don't give this as an answer because it's asking you for the angle measures. So you have to plug the 3 in here and also here and figure out what that's going to be. So this one would be 2 times 3, which is 6, plus 13, which is 19. So 19 degrees. And then the other one, 20 times 3 is 60. 60 plus 11 is going to be 71, so that's 71 degrees. And again, you can always check your work. If you have complementary angles, they're going to be two positive angles, and the sum's going to be 90 degrees. So these are both positive angles, and if I sum them, 19 degrees plus 71 degrees is 90 degrees. Okay, let's look at problem number 8. So very similar to the last problem. So we have this 3x minus 4 degrees and 12x plus 19 degrees. Again, these are complementary angles. So I could just say 3x minus 4 plus 12x plus 19 is equal to 90. So 3x plus 12x is 15x. Negative 4 plus 19 is going to be 15, and this equals 90. So let's subtract 15 away from each side of the equation. This cancels. 15x is equal to 90 minus 15 is going to be 75. Let's divide both sides of the equation by 15. We'll cancel this. We'll say that x is equal to 75 divided by 15 is 5. So x is 5. Again, we're not done. Please don't give that as your answer. You need to go back and calculate the measure of each angle. So I'm going to plug in a 5 here and also here. So 3 times 5 is 15. 15 minus 4 is 11, so this is 11 degrees. The other one, 12 times 5 is 60. 60 plus 19 is 79, so 79 degrees. Again, you can check this. They're both positive, and 11 degrees plus 79 degrees is 90 degrees, so these guys are good to go. All right, for the last two problems, we want to find the measure of the supplementary angles. So remember, these angles are going to be positive angles that sum to 180 degrees. So you have your 3x plus 10, then plus your 15x minus 10. This equals 180. Again, you can just leave the degree symbol off. We'll just put it in later. So I will say that 3x plus 15x is 18x, and then 10 minus 10 is 0, so that's gone. So 18x equals 180. Divide both sides by 18. I think you can see that this is going to cancel, and we'll have x is equal to 180 over 18 is 10. Okay, so x is 10, and again, I'm just going to plug that in everywhere there's an x. So here and here, to figure out these angle measures. So 3 times 10 is 30, plus 10 is 40, so this is 40 degrees. And then for the other one, 15 times 10 is 150, and 150 minus 10 is 140, so this is 140 degrees. So again, these are two positive angles, and the sum is 180 degrees. Obviously, 40 degrees plus 140 degrees would give me 180 degrees. Okay, let's look at problem 10. So here, we're going to have 14x plus 11 degrees and 34x plus 25 degrees. Again, we're looking for these two supplementary angles. So the sum, once again, is going to be 180 degrees. So I'll just say that 14x plus 11 and then plus 34x plus 25 is equal to 180. So let's start with 14x plus 34x. That's going to give us 48x. And then 11 plus 25. That's going to give us 36. So let's go plus 36, and this equals 180. What we'll do from here is subtract 36 away from each side of the equation. So this is going to cancel. We'll have 48x is equal to 180 minus 36. That's going to be 144. Let's divide both sides of the equation by 48. So this is going to cancel, and we'll say x is equal to 144 divided by 48 is going to be 3. So again, x equals 3 is not the answer. That's just the first part. So we do have to plug in and figure out the final answer. So I'm going to plug in a 3 here and plug in a 3 here. So 14 times 3, that's 42, and then plus 11, that's going to be 53. So this is 53 degrees. And then the other one, 34, multiplied by 3 is 102. And then if I add that to 25, I get 127. So this is 127 degrees. So again, these are two positive angles, and the sum is going to be 180 degrees. So this is going to be our correct answer. All right, let's take a look at the practice test. We're told to perform each calculation. And for the first problem, we're going to add these two angles together. We have 36 degrees, 15 minutes, 13 seconds, plus we have 18 degrees, 55 minutes, 51 seconds. Okay, so my preference is to do this vertically. You don't have to, but I think it makes it a little bit easier. So we're going to start out with a column for degrees. So we're going to say 36 degrees. Then you'll have a column for minutes, so 15 minutes. And then you're going to have a column for seconds, so 13 seconds. Okay, let me slide this over actually a little bit. I'm going to put plus, let's go 18 degrees, then 55 minutes, and then 51 seconds. Okay, let me put my little bar down here. All right, so let me put a little border here. And I'm just going to write something from the lesson that you should remember. So we know that 1 degree is equal to 60 minutes. And then also 1 minute is equal to 60 seconds. Okay, so using this, if we get an answer in either the minutes column or the seconds column that is 60 or larger, or you could also say that is greater than 59, you need to convert it over. So I'll show you what I mean on this one. So first and foremost, starting in the rightmost column, we have 13 seconds plus 51 seconds. So we know that 13 plus 51, that's going to give me 64. So if you write 64 seconds down here, the problem is that this is 60 or larger, so you need to convert it over, okay? So what I'm going to do is just write this off to the side and say 64 seconds is really, just using this, I'm going to break it up into 60 seconds plus 4 seconds. And we know from this guy right here that 60 seconds is 1 minute. So I could just replace this guy right here with 1 minute. So I can say this is 1 minute plus 4 seconds. Okay, so how am I going to relay that information in terms of this problem? Well, I'm going to keep this column right here strictly in terms of seconds. So I'm going to take my seconds, which is 4, so 4 seconds. And then I'm going to carry the minutes over to the left into that column, just like if I was adding numbers using a vertical format. So it's very similar. So I'm just going to put this up here and say this is 1 minute up there. Okay, let's get rid of this and let's add in this column. So now we have 1 minute plus 15 minutes, that's 16 minutes, and then plus 55 minutes. That's going to give me 71 minutes. So 71 minutes. But again, this number falls into the category where it's 60 or larger, so we can convert it over. So I'm going to say that this is 71 minutes here. And again, using this relationship here, I'll break this up and say this is 60 minutes plus 11 minutes. And again, I know that 60 minutes from this guy right here is 1 degree. So I'll go ahead and say this is 1 degree plus 11 minutes. And so instead of writing 71 minutes there, I'll say that this is 11 minutes. And then I'll carry this 1 degree over into this column like this. Okay, so that's all we have to do. Now, in this leftmost column where we're dealing with degrees, this can be as high as you want. Okay, so it can be 60 or greater, it does not matter. Okay, so we're going to say that this is 1 degree plus 36 degrees plus 18 degrees. So 1 plus 36 is 37. 37 plus 18, that's going to be 55. So this is 55 degrees. Okay, so this gives us our final answer. We're going to have 55 degrees, 11 minutes, and 4 seconds. All right, let's take a look at problem number 2. So here we have 121 degrees, 13 minutes, 11 seconds. We're going to subtract away 14 degrees, 50 minutes, 19 seconds. So let me just write this one on top. So 121 degrees, 13 minutes, 11 seconds. And I'm just going to match that down here. So let me put the minus. We have 14 degrees. We have 50 minutes and 19 seconds. Okay, so let me put this like this. Let me put my bar down here. And I'm just going to write that relationship one more time. So we know that 1 degree is equal to 60 minutes. And we know that 1 minute is equal to 60 seconds. So we're going to use that again. Now, when you go to subtract, again, just like if you were working with subtraction on an example where you're doing a vertical subtraction, the top number needs to be greater than or equal to the bottom number, right? We don't have that. 11 is less than 19. So what you're going to do is just borrow, right? So I'm going to look over here in the next column to the left, and I'm going to say, hey, I have 13 minutes here. Well, 13 minutes can be written as 12 minutes plus 1 minute, right? I didn't do anything illegal. And I'm going to convert this 1 minute over into 60 seconds. So let me just write this as 60 seconds here. And so I'm going to cross this out and say that I have 12 minutes here. And then I'm going to take the 60 seconds and move it into this column. So let me cross this out and say I have 11 seconds plus 60 seconds. That's going to be 71 seconds like this. And so now we can do our subtraction. So 71 seconds minus 19 seconds, that's going to be 52 seconds. Okay, now moving to the left, I have a problem again, because now I have 12 minutes minus 50 minutes. So again, I'm just going to borrow. So I'm going to cross this out and say this is 120 degrees. And with that 1 degree, again, that's 60 minutes. So I can just add 60 minutes to what I have here, which is 12 minutes. And so 60 plus 12 is 72. So let me just line this out and put this as 72 minutes. And now I can just say 72 minutes minus 50 minutes is going to be 22 minutes. And then moving to the left, now I have 120 degrees minus 14 degrees, and that's going to be 106 degrees. So this would be our final answer. We have 106 degrees, 22 minutes, 52 seconds. Okay, let's take a look at the third problem now. So we have 18 degrees minus 17 degrees, 14 minutes, 17 seconds. So you have your 18 degrees. Let me just write it like this for right now. You're missing minutes and seconds. So let me put 0 minutes and let me put 0 seconds, and we'll change that in a moment. So then we have minus. For this guy, we have 17 degrees. We have 14 minutes, and we have 17 seconds. Let me actually slide this over a little bit. Let me put my little bar down here. And again, let me write this relationship. So 1 degree is equal to 60 minutes, and then 1 minute is equal to 60 seconds. Okay. So this number right here is smaller than this number right here. So again, we're going to borrow. But we have to go all the way to the left to borrow. So I'm going to cross this out and put this as 17 degrees. So that 1 degree that I lost, again, 1 degree is 60 minutes. So I'm going to cross this out and put 60 minutes. But I still need to borrow again, so I'm going to cross this out and put 59 minutes. And then again, that 1 minute that I lost, 1 minute is 60 seconds. So I'm going to cross this out and just put this as 60 seconds. So now I'm good to go. I can say 60 seconds minus 17 seconds. That's going to give me 43 seconds. And then moving to the left, 59 minutes minus 14 minutes. That's going to be 45 minutes. And then 17 degrees minus 17 degrees is 0. So you could put 0 degrees if you wanted to. Some teachers want that. Others don't care. So this is my preference. I would just say that you have 45 minutes, 43 seconds. But again, if you wanted to say you had 0 degrees, 45 minutes, 43 seconds, it's really the same thing. All right, for the next two problems, we're told for the given angle measure, find the measure of its complement, okay? So the complement, when we think about complementary angles, they're two positive angles such that the sum is 90 degrees, okay? So together they would form a right angle. So for problem number 4, we have 76 degrees, we have 22 minutes and 14 seconds. So to find the complement, you just take 90 degrees and subtract this away, okay? So I'm going to set this up and say this is 90 degrees. And then I'll say it's 0 minutes and 0 seconds. Let me write this. This is 76 degrees, 22 minutes, 14 seconds. Okay, let's come down here. Let me put my minus sign here. And again, I'm just going to keep writing this relationship so we remember it. It's 1 degree is 60 minutes. And then it's 1 minute is 60 seconds. Okay, so I'm just going to go through and borrow. I think we know how to do this at this point. So this, I'm going to take a degree away. So this will be 89 degrees. That 1 degree is 60 minutes. So I'm going to basically cross this out and put this as 60 minutes. And I'm going to need to borrow again. So let's cross this out and take 1 minute away. So now I have 59 minutes there. And with that 1 minute, I'm going to convert that into 60 seconds. So I'm just going to cross this out and say this is 60 seconds. So 60 seconds minus 14 seconds would be 46 seconds. And then 59 minutes minus 22 minutes, that would be 37 minutes. Then lastly, we would have 89 degrees minus 76 degrees. That's going to be 13 degrees. So the complement of this angle, that's 76 degrees, 22 minutes, 14 seconds, is going to be 13 degrees, 37 minutes, 46 seconds. All right, for problem 5, again, we want to find the complement. And once again, we say that two complementary angles are positive angles such that the sum is 90 degrees, or when you sum them, you get a right angle. So to set this up, I'm just going to say we have 90 degrees, and then we're going to subtract away the 11 degrees, 59 minutes, 10 seconds. Let me slide this over a little bit so I can fit everything. Let me put my bar here, and then I'll put that 1 degree is equal to 60 minutes, and then I'll put that 1 minute is equal to 60 seconds. Okay, over here, again, I'm just going to borrow and convert things. So I'm going to borrow here 1 degree, so this will be 89 degrees, and 1 degree is 60 minutes. So I'm just going to put this as 60 minutes here. And again, I need to borrow, so when I borrow 1 minute, I'll say this is 59 minutes now, and basically that 1 minute that I borrowed away, that's going to be 60 seconds, so let's put this as 60 seconds. Okay, so 60 seconds minus 10 seconds is 50 seconds. 59 minutes minus 59 minutes is 0 minutes. And then 89 degrees minus 11 degrees, that's going to be 78 degrees. So the answer for the complement of this angle, which is 11 degrees, 59 minutes, 10 seconds, is going to be 78 degrees, 0 minutes, 50 seconds. You could also more cleanly write this as just 78 degrees and 50 seconds. All right, for the next problem, we're given this where we say for the given angle measure, find the measure of its supplement. So now when we think about supplementary angles, there are two angles that are positive angles and the sum is 180 degrees. So if you sum them together, you're getting a straight angle. So for problem number 6, we're given 43 degrees, 19 minutes, 9 seconds. So what we'll do is take 180 degrees. We'll subtract away this 43 degrees, 19 minutes, and 9 seconds. Let me slide this over so this fits. Let me put this bar down here. And we'll say again that 1 degree is 60 minutes. And then we'll say that 1 minute is going to be 60 seconds. Okay, so we know the deal already. We're going to borrow. So I'm going to take 1 degree away. That's 179 degrees now. And with that 1 degree, that's 60 minutes. So we'll say this is 60 minutes. And then I'm going to borrow from this. So I'm going to borrow 1 away. So let's write this as 59 minutes. And with that 1 minute that I borrowed away, it's 60 seconds. So let's write 60 seconds here. So 60 seconds minus 9 seconds is 51 seconds. 59 minutes minus 19 minutes, that's going to be 40 minutes. And then when we think about 179 degrees minus 43 degrees, that's going to be 136 degrees. So if you're asked for the supplement of this angle, which is 43 degrees, 19 minutes, 9 seconds, where you're going to get 136 degrees, 40 minutes, 51 seconds as your answer. All right, so now what we want to do for the next two problems is convert to degrees, minutes, and seconds. So looking at this for problem 7, we have 139.73 degrees. Now your calculator will do this for you if you have a TI calculator, but sometimes your teacher will ask you to do this manually, and so you do need to know how to do this. So basically you take this part right here, the part that comes before the decimal point, and you just keep it. Okay, so I'm going to put this as equal to 139 degrees. Okay, now I'm missing the minutes and I'm missing the seconds, so we have to put those in. So what you do is you take this 0.73 degrees here, and first you're going to figure out, well, how many minutes would that give me? Okay, so to do that, again, if I write this relationship, we have that 1 degree is equal to 60 minutes. So we know this from pre-algebra that basically we set up a unit fraction. Okay, so these two are equal. So what I'm going to do is put the 60 minutes in the numerator, and I'm going to put the 1 degree in the denominator. Remember, because these are equal, it has a value of 1, right? So I'm multiplying by 1. I'm not changing anything. But what's going to happen is I put the units I didn't want in the denominator, so the degree unit is going to cancel away. And basically, I have 0.73 times the 60, and that's going to give me 43.8, and this is in terms of minutes. Now, again, I don't want the decimal point there. So what I'm going to do is just take the whole number part, so the 43, and that's how many minutes I'm going to say that I have. So I'm just going to erase this, and now I'm going to think about the seconds. So I have 0.8 minutes. Okay, so 0.8 minutes. Converting that over to seconds, again, now I'm going to use the relationship where I say that 1 minute is equal to 60 seconds. Again, just set this up as a unit fraction, so I'm going to multiply by. I'm going to put the units that I don't want in the denominator. So I'm going to put the 1 minute down here, and I'm going to put what I do want in the numerator, so 60 seconds up here. Again, 60 seconds is equal to 1 minute, so this is basically like multiplying by 1. So what I'm going to do here is cancel this unit here of minute with this unit here of minute, and you get 0.8 times 60, which is going to give me 48, and I'm using these units, so this is seconds, so now I have 48 seconds. Okay, so when we convert this over, you're going to end up with 139 degrees, 43 minutes, 48 seconds. Okay, let's look at problem 8. So here we have 211.915 degrees. So again, just start off with this whole number part. You're just going to grab it. So 211 degrees. Then you have a certain number of minutes and a certain number of seconds. Again, you're just going to work with that decimal part. So this 0.915 degrees. And I'm going to multiply it by, again, think about the relationship between degrees and minutes. So 1 degree is equal to 60 minutes. So I'm going to put what I don't want in the denominator. I don't want degrees anymore. I want minutes. So I'm going to say this is 60 minutes over 1 degree. Again, just like multiplying by 1. So I'm going to cancel this unit with this unit. And then 0.915 times 60, that's 54.9. So let me put this as 54.9. And then this is in terms of minutes. And again, I just want to grab the whole number from this. So just the 54. So 54 minutes. I want to deal with the 0.9 minutes separately. So we're just going to do the same thing. So we're going to say that we have 0.9 minutes. And again, thinking about the relationship between minutes and seconds, you have 1 minute is equal to 60 seconds. So again, I'm going to multiply this by, think about what you don't want, put that in the denominator, right? So I'm going to say 60 seconds, that's what I do want, goes in the numerator, over 1 minute, that goes in the denominator because I don't want it. So then this unit here will cancel with this unit here. And you just do your multiplication. So 0.9 times 60, that's going to give you 54. And then again, grab these units, so that's going to be seconds. So this is 54 here. Okay. So converting this over, we basically get an answer of 211 degrees, 54 minutes, 54 seconds. All right, let's take a look at the final two problems where we want to convert to decimal degrees to the nearest thousandth. So when we talk about the nearest thousandth, that's going to be 3 decimal places. So looking at the problem, for number 9, we have 39 degrees, 55 minutes, and 11 seconds. So let me just write some relationships here. We know that 1 degree is equal to 60 minutes. We also know that 1 minute is equal to 60 seconds. And in the lesson, we talked about the fact that 1 degree was equal to 3,600 seconds. And again, that's pretty easy to figure out. If you just start with 1 degree and you multiply by 60 minutes over 1 degree, so that the degree unit is going to cancel, and then you multiply by 60 seconds over 1 minute, so that the minute unit is going to cancel, well, what are you left with? You're left with 60 times 60, which is 3,600, and your units are going to be in terms of seconds. So this is 3,600 seconds, so that's where that relationship is coming from. Okay, so now that we understand that, we're ready to convert this over. So everything is basically going to get converted over to a degree unit. And so let me put equals here. I'm going to start with 39 degrees, and then I'm just going to say plus. I'm going to say I have 55 minutes. If I wanted to convert that over, I would look at this relationship here. Again, always think about the units you don't want and put them in the denominator. Okay, that's all you have to remember. So I'm going to say this is times. I want to put 1 degree in the numerator. That's what I want. And then over your 60 minutes in the denominator. I don't want minutes, so that's why it goes down there. So this unit will cancel with this unit, and so I'll be left with degrees. So really at this point, I could say this is 55 over 60 degrees. So let me put that this is 55 over 60. And you could wrap this and put degrees. You could just put the degrees right there for right now. It really doesn't matter. Then I'm going to put plus. For this 11 seconds, again, I'm going to do the same thing. So 11 seconds, and I look at this relationship here. I want to end up with degrees. So I'm going to multiply by 1 degree and put that in the numerator over 3,600 seconds. Again, what I don't want is seconds, so I put that in the denominator. So this is going to cancel. So you get 11 over 3,600. So 11 over 3,600 degrees. Now, you could divide this on your calculator and divide this on your calculator and add those two decimals together. That gets a little bit nasty in a lot of situations, and sometimes you don't get the same answer, and sometimes you do. So it just depends on the situation. What I'm going to do is show you a longer way, and in a lot of cases, it's going to be more accurate. Again, sometimes it doesn't make any difference at all. So I'm going to say that this is 39 degrees, and then plus, I'm going to get a common denominator here. Let me actually get rid of this for right now. I'm just going to wrap this and put the degree symbol out here. So I'm going to multiply this by 60 over 60. And so that will give me 55 times 60, which is 3,300. And then this is over 3,600 plus 11 over 3,600. So you see you have a common denominator. So 3,300 plus 11 is going to be 3,311 or 3,311. And this is over the common denominator of 3,600. And then you could put your degree symbol out here. And so this would be equal to what? So if I divide this on my calculator, I'm going to get, let me write this 39 first. So 39 point, you're going to have 919 and then 7, and that 2 is going to repeat forever after that. So let me put my degree symbol there. If we wanted to round this to the nearest thousandth, again, tenths, hundredths, thousandths. So I'm looking at this guy right here, and my decision digit is the 7. So the 7 is in the category of 5 or larger, so I want to round up. Now this one's tricky because this is a 9. So if I try to add 1 to 9, I get 10. So basically I have to make this into a 0, and I have to add 1 here to make this into a 2, and then I can cut the 0 off because it doesn't add any value. So this becomes 39.92 degrees. Now, these are not exactly equal because I went from a fraction to a decimal. So in this step right here, I'm just going to put the approximately symbol just so that this is accurate. A lot of teachers let you put equal. They don't care. But I'm just going to be consistent with what you'd see in a book. So this is approximately 39.92 degrees. All right, let's take a look at problem 10. So here we have 191 degrees, 17 minutes, 50 seconds. Again, to convert this over, I'm going to take my 191 degrees, then plus, I have my 17 minutes, and I'm going to multiply this by, again, 1 degree is 60 minutes. So I'm going to put 1 degree up here over 60 minutes down here, And these units are going to cancel. And so I end up with 17 over 60 degrees. So 17 over 60 degrees. Then plus you have your 50 seconds here. And again, we think about 1 degree is equal to 3,600 seconds. So I'm going to multiply this by 1 degree over 3,600 seconds. And let's show this is canceling with this. So this is 50 over 3,600 degrees. So 50 over 3,600 degrees. Now, to make this problem easier, you could cancel a 0 between the numerator and denominator. That just means you're canceling a factor of 10, right? So I can get rid of this and get rid of this. And now, if I wanted to get a common denominator, let me get rid of this. Let me wrap this like this and put this like this. Let me multiply this by 6 over 6. So 17 times 6, that's 102. So you'd have 102 plus 5, which is 107. So this would be 107. So 107 over 360 degrees. So let's punch this into the calculator. You're going to have the 191 and then 0.29 and then 7. And then you have the 2 that repeats forever and then degrees. Okay. So what I'm going to do again is round this to the nearest thousandth. So I'm looking at this guy right here, and the digit that follows is a 2, right? So that falls in the category of 4 or less. So I would round down. So let's get rid of this, put this like this, and I'm going to change this to approximately here because it's not exact, it's approximately, but it's what we were told to do. So this is the answer. So we have 191.297 degrees. Let's take a look at the practice test. We're told to state if the two angles are coterminal angles. And for the first problem, we have 150 degrees and 510 degrees. So how can we determine if these two angles are what we call coterminal angles? So coterminal angles have the same initial side and the same terminal side, but their measures are going to differ by some multiple of 360 degrees. So the way we could figure this out is we could do a basic subtraction. Okay, it doesn't matter the order because if you change the order, you're just going to change the sign of your result. So I could do 150 degrees minus 510 degrees, and that would give me negative 360 degrees. Or I could do it in a different order, and I could say this is 510 degrees minus 150 degrees, and this would give me positive 360 degrees. Either way, I'm just looking at the answer, and I'm trying to see, is it some multiple of 360 degrees? Obviously, either way, you could say that it is, right? This is basically negative 1 that is being multiplied by 360 degrees to give me negative 360 degrees. And this would be positive 1 times 360 degrees to give me 360 degrees. So in each case, no matter how you do it, you're going to get a result that's a multiple of 360 degrees. So you would answer yes, that these guys are coterminal. Okay, let's look at problem number 2. So we have 70 degrees and 610 degrees. So again, you can subtract in either order. It's probably easier mentally to take the bigger one. So 610 degrees minus 70 degrees. And this is going to give me 540 degrees. Some people will know right away that this is not a multiple of 360 degrees. Some people don't. So what I suggest is just to punch it into your calculator. Just take 540 and divide it by 360 and see if you get a non-zero integer. Okay. If you do, then these guys are coterminal. If you don't, then they're not coterminal, okay? So if you divide 540 by 360 in your calculator, you're going to get 1.5. So that is not a non-zero integer, so these guys are not coterminal, right? So this is a no. This 540 degrees here, that's not a multiple of 360 degrees. Okay, let's look at problem 3. So we have 325 degrees and 525 degrees. So let me just say that we have 525 degrees minus 325 degrees. And so this would give me 200 degrees. I think we can all see that without doing a division, that this would not be a multiple of 360 degrees. So I'm just going to put a no here. Again, you can always divide 200 by 360 in your calculator, and that's going to give you a 0.5 where the 5 repeats forever. So obviously that's not a non-zero integer. So this is a no here. 200 degrees is not a multiple of 360 degrees. Okay, let's look at problem 4. So here we have 280 degrees and negative 80 degrees. So you have to be very careful when you have these negative angles. Remember, you can produce a negative angle by rotating clockwise. So I would still do my subtraction. So I would go 280 degrees, but here I'm going minus a negative. Okay, so you have to keep that in mind. When you do minus a negative, it's plus a positive. So this is 280 degrees plus 80 degrees, which is equal to 360 degrees. So yes, these guys are going to be coterminal angles. Okay, let's look at problem number 5. So we have 255 degrees and then negative 105 degrees. So again, we have another negative angle here. So let's go 255 degrees minus a negative 105 degrees. So again, minus a negative is plus a positive. So you have 255 degrees plus 105 degrees. So that's going to give me 360 degrees. So again, this is a yes. These guys are coterminal angles. Okay, let's look at 6. So we have 225 degrees and negative 135 degrees. So let's go 225 degrees minus a negative 135 degrees. So this would be 225 degrees, then plus 135 degrees, and that's going to once again be 360 degrees. So yes, these guys are coterminal angles. All right, let's talk about a different type of problem. So now we're asked to find a coterminal angle between 0 degrees and 360 degrees. So for problem 7, we're given 645 degrees. And the idea here is if you're given a positive angle, like we have here, we're going to keep subtracting away 360 degrees until we get an angle measure that's between 0 degrees and 360 degrees. If you got a negative angle measure, well, then you need to add 360 degrees until you get to an angle measure that's between 0 degrees and 360 degrees. So for this one, let's take 645 degrees. Let's subtract away 360 degrees. Let's key that into our calculator, and we're going to get an answer of 285 degrees. So this is the answer we want, this 285 degrees. So it's a coterminal angle with 645 degrees, and it's between 0 degrees and 360 degrees. All right, for problem 8, we have negative 105 degrees. So again, because this is negative here, I'm now going to add 360 degrees. So we'll have negative 105 degrees plus 360 degrees, and that's going to give me 255 degrees. So this is the coterminal angle that I want. Again, you want it to be between 0 degrees and 360 degrees. Okay, let's look at problem number 9. So here we have 635 degrees. So again, I'm just going to subtract 360 degrees away, and that's going to give me 275 degrees. So let's put that as our answer. So 275 degrees is the coterminal angle that I'm looking for. It's between 0 degrees and 360 degrees. All right, for problem 10, we have 990 degrees. So for this problem, we have to do a little bit more work. If you do 990 degrees and you subtract away 360 degrees, you're going to find a coterminal angle, but it's not between 0 degrees and 360 degrees like we were told to find. So this would put me at 630 degrees. So I would have to subtract again. So we would go 630 degrees minus 360 degrees, and this would give me 270 degrees. So this is the answer I'm looking for. Again, we had to find a coterminal angle that was between 0 degrees and 360 degrees. So this one is a coterminal angle, but it doesn't work because it's not between 0 and 360 degrees, right? So we have to subtract again to get this 270 degrees so that it's between 0 degrees and 360 degrees like we were told. All right, let's take a look at the practice test. For the instructions, we're told that M and N are parallel lines, and we want to find the measure of the two marked angles. So coming down here, when we look at this first problem, we're given this angle right here that we want to find the measure for, and then also this angle right here. Now, what do we know about this guy? We know that this line right here that's in, I guess you could call it blue or maybe turquoise or something like that, but this line is called a transversal, right? So basically it's intersecting these two parallel lines. So these 8 angles that are formed, we talked about those in the lesson, and this angle right here and this angle right here, those are known as alternate interior angles. So with alternate interior angles, they're going to be equal in measure. So what I can do for this problem is I can just say that 5x plus 15, forget about the degree symbol for right now, you don't need it. We'll say that's equal to this guy right here, so the 9x minus 13. Again, forget about the degree symbol for right now. So what I'm going to do is solve this equation for x, and then I'm going to plug into either one, and I'll have my answer. So what I'll do is say I'm going to subtract 9x away from each side of the equation. This will cancel. I'm going to subtract 15 away from each side of the equation. This will cancel. So 5x minus 9x is negative 4x. And this equals negative 13 minus 15 is going to be negative 28. We'll divide both sides of the equation by negative 4. This will cancel. You'll get x is equal to 7. Okay, let me get rid of this. And 7 is not the answer. You do have to plug back in. So you have to say that 5 times, I'm going to put a 7 in there, plus 15. So we're going to simplify this, and that'll be our answer in terms of degrees. So 5 times 7 is 35, and then 35 plus 15 is going to be 50. So this is going to be 50 degrees. So I'll just answer that by putting it in here. So this is 50 degrees, and then this guy is going to be 50 degrees as well. All right, let's take a look at the next problem. For the instructions, we have that M and N are parallel lines, and we want to find the measure of all 8 angles. All right, for problem 2, we're looking at this guy here. It's very similar to what we saw in problem 1. We have this, I guess turquoise is the color, I'm not really sure, but this line right here would be a transversal. Again, what it's doing is it's cutting through, or you could say intersecting these 2 parallel lines, M and N. So we have these 8 angles that are formed. Again, we talked about the properties of these 8 angles in the lesson. So what I would see here is that if I'm trying to find the measure of all 8 angles, I'm given the measure of angle 1. It's negative 15x plus 70, that quantity degrees. I'm given the measure of angle 7. It's 13x plus 104, that quantity degrees. Well, what I know from the lesson is that with angle 7 and angle 2, they are known as alternate exterior angles, and alternate exterior angles are equal in measure. So what I can do is just take this right here and copy it up here. So this is the quantity, 13x plus 104. Let me close that down, and then degrees. Okay, so what can I say about the measure of angle 1 in relation to the measure of angle 2? Well, their sum would be 180 degrees, right? Because this would be a straight angle. So what I can do is just say that negative 15x plus 70, forget about the degree symbol for right now, then plus 13x plus 104, this would be equal to 180. Let me actually take this to a separate sheet, just so we don't run out of room. And so I'm just going to solve this real quick. So negative 15x plus 13x, that's negative 2x. We have 70 plus 104, which is basically plus 174, and this equals 180. So let me subtract 174 away from each side of the equation. This will cancel. You'll have negative 2x is equal to 180 minus 174 is 6. Let's divide both sides by negative 2, and we're going to find that x is equal to negative 3. Now, this is not your answer. You're going to come back up here, and you're just going to plug in for x. So I know that x is equal to negative 3. So for this one, you have negative 15 times negative 3, and then plus 70. So this is going to be your degrees. So negative 15 times negative 3, that's going to be positive 45. And 45 plus 70, that's going to be 115. So let me erase this and just put that this is 115 degrees. Now, for this one, you could plug in the negative 3 if you want, or you can just do 180 minus 115. Either way, you're going to get 65 degrees. So let me actually erase this, and I'm going to erase this and just put 65 degrees. Now, once you have these two, you basically have the rest. First off, I know that, again, alternate exterior angles are going to be equal in measure. So this guy right here, this 2 and the 7, they're going to have the same measure. So let me just write 65 degrees in there like that. And then 1 and 8, those are going to have the same measure. They're alternate exterior angles. So this is going to be 115 degrees. Now for the rest of them, you could think about 1 and 4 as vertical angles. So basically they're going to have the same measure. So for this one, it's going to be 115 degrees. And then 2 and 3 are vertical angles. So they would have the same measure. So this is 65 degrees here. And then I'm going to do the same thing here. So 5 and 8 would have the same measure. Those are vertical angles. So let me change the color up. So this would be 115 degrees here. And then 6 and 7 are vertical angles, so they have the same measure. So this is 65 degrees here. Okay, so angles 1, 4, 5, and 8 are all going to be 115 degrees. And then angles 2, 3, 6, and 7 are going to be 65 degrees. All right, for the next problem we have for the instructions, we want to find the measure of all 3 angles. So for problem 3, this is what we're looking at. We have a triangle, and the measure of angle 1 here, it's 2x plus 25, this quantity degrees. The measure of angle 2, it's 3x minus 20, that quantity degrees. And the measure of angle 3, it's 6x minus 100, that quantity degrees. Now we know that the sum of the measures of the angles of any triangle is 180 degrees. So what we would do here is just take 6x minus 100, forget about the degree symbol in each case, then plus, we're going to take this 2x plus 25, then plus, we're going to take this 3x minus 20, and I'm running out of room here, so let me grab this, and let me paste this in. I'm going to set this equal to 180. Okay, so we have 6x plus 2x, that's 8x, and then plus 3x, that's 11x. So let me write here, this is 11x. Then we have negative 100 plus 25, that's going to be negative 75. And then if we subtract away 20, that's going to be negative 95. So let's put minus 95 here. This equals 180. Let's add 95 to both sides of our equation. Let's cancel this away. We'll say that we have 11x is equal to 180 plus 95. That's going to be 275. And what I'll do now is divide both sides of the equation by 11. This will cancel. We get x is equal to 275 divided by 11. That's going to be 25. All right, so let's come back here. I'm just going to write that x is 25. This is not your answer. You do need to plug in. So for angle 1, if we think about the measure, we have 2x plus 25, that quantity degrees. So just plug in a 25 here. So 2 times 25 plus 25. Again, this quantity degrees. So 2 times 25 is 50. 50 plus 25 is 75. So this is 75 degrees. So I'm just going to put 75 degrees right there for the measure of angle 1. Now, if I think about the measure of angle 2, this is going to be the quantity 3 times 25. Just plugging that in for x right there. Then minus 20. Again, this is degrees. So 3 times 25 is 75. 75 minus 20 is 55. So this is 55 degrees. Okay, let me get rid of this. I'm just going to put this as 55 degrees. Let me make that 5 a little bit better. Now, at this point, you could say 180 minus the sum of these two. 75 plus 55 is 130. So if you did 180 minus 130, you would get 50. So the measure of angle 3 would be 50 degrees. And again, you could also plug in if you want to do it that way. You could say 6 times 25 is 150, and then 150 minus 100 is 50, so either way it's 50 degrees. So the measure of angle 1 is 75 degrees, the measure of angle 2 is 55 degrees, and the measure of angle 3 is 50 degrees. All right, for the next problem, the instructions tell us to find all unknown angle measures in each pair of similar triangles. And we are told that triangles ABC and EFD are similar. So this is what we're looking at for problem 4. Again, we're saying that triangles ABC and EFD, those are similar triangles. So with similar triangles, corresponding angles will always have the same measure. So in this problem, our angle A corresponds to our angle E, our angle C corresponds to our angle D, and our angle B corresponds to our angle F. Now we are given some information. So for angle A, the measure is given as 12x minus 12, that quantity degrees. For angle C, we have that the measure is 30 degrees. And for angle F, we're given that the measure is 5x minus 25, that quantity degrees. Well, since angle B corresponds to angle F, and again, corresponding angles have the same measure, I can write in here that for angle B, it's 5x minus 25, this quantity degrees, okay? So what I can do now is use the fact that the sum of the measures of the angles of any triangle is 180 degrees. So I'll take this 30 degrees. Again, I'm just going to leave the degree symbol off, so just 30. Then plus, let's take this one, so 5x minus 25. Then plus, let's take this one, so 12x minus 12. And let's set this equal to 180. Let's go through and solve. So we have 5x plus 12x, that's 17x. So 17x. Then you have 30 minus 25, that's 5. And then minus 12, that's going to be negative 7. And this equals 180. So let me add 7 to both sides of the equation. We'll cancel this. We have 17x is equal to 180 plus 7 is 187. Let's divide both sides of the equation by 17. We'll show this as canceling. And we'll say that x is equal to 187 divided by 17 is going to be 11. So coming back up here, let me just write that x equals 11. Again, this is not your answer. You need to plug back in. So for this one right here, we had that 5 times x is 11, minus 25. So this quantity degrees. So 5 times 11 is 55. And then 55 minus 25, that's going to be 30. So this is 30 degrees. So at this point, you can erase this. And you can put this one as 30 degrees. Let me see if I can make that a little bit better there. Now for angle A, you could plug in if you wanted to. 12 times 11 is 132. And then 132 minus 12 is 120. So this is going to be 120 degrees. Let me actually just arrow to this and say this is 120 degrees. I don't think I could fit that in there. And basically, you could have also said that 30 degrees plus 30 degrees is 60 degrees. And you could have said, well, the sum is 180 degrees. 180 degrees minus 60 degrees is 120 degrees. So that's another way to figure that out if you want to do it that way. So angle A and angle E, those are both going to have a measure of 120 degrees. Let me see if I can just put that in there. I think it'll fit there. And then angle C and D would be 30 degrees. So let me actually put an arrow going there and say this is 30 degrees. And then for angle F and angle B, that's also 30 degrees. So let me just say this is 30 degrees. And of course, you could write this out if you wanted to. I could say that the measure of angle A is going to be 120 degrees. And then the measure of angle E is going to be 120 degrees. And then the measure of angle C, and then also for angle D, that's going to be 30 degrees in each case. And we know that the measure of angle F and the measure of angle B, that's going to be 30 degrees in each case. Okay, so this would be your solution for this problem. All right, for the next problem, we want to find the lengths of all unknown sides for the similar triangles. We are going to state here that triangles ABC and DEF are similar. So coming down to problem number 5, let me just write this formally. So we'll say that this triangle ABC, so this is ABC for the triangle. We'll say this is similar to this other triangle here, and this is going to be DEF. So DEF. And again, this has to match up when you're reading this guy. So in other words, this angle A is going to correspond to this angle D. So you have A here and D here, and you can see that you have a single arc here and a single arc here. So that's how you can find corresponding angles as well. The other guy B here, which is second here, and E here, which is second here, those two are corresponding angles. So you have angle B and angle E. And again, those both have double arcs. And then lastly, you have angle C that's going to correspond to angle F. So here is C, here is F, there's triple arcs in each case. Okay, so this problem actually deals with finding unknown side lengths. So we don't know the length of this side or this side. So how are we going to figure that out? Well, basically, you're going to set up a proportion. We know with similar triangles that corresponding angles are equal, but also the corresponding sides must be proportional. Okay, and all that means is that the ratios of their corresponding sides must be equal. So in other words, let's say I start with any two corresponding sides, okay? And you can get this from the statement. Let's say I go with side AB and side DE. Those are corresponding sides. So here's side AB and here's side DE. So I'm going to set up a ratio, and I'm going to do this as a fraction. So I'm going to take the length of side AB, and let me just put AB for right now, and I'll put this over, or in a ratio you could say 2, the length of the side DE. So that's going to just be DE like this. So we're saying this is equal to, you could set up the same thing for any two other corresponding sides. So my side BC here is going to correspond to my side EF. So what I'll do is set this up and say the length of the side BC to the length of the side EF. So this guy right there. So again, these two ratios should be equal. And I could set up another one here with the remaining guy. So I could say the side AC is going to correspond to the side DF. And so I want the ratio where I say the length of the side AC, so let me put that like that, to the length of the side DF. So this guy over here, so let's put that like that. Now, once you've set this up, just go through and plug in what you know, and then you can solve for what you don't know. So the length of the side AB is 2.5. So let's put that in there like that. The length of the side DE is 4. So let's put that in there like that. And then the length of the side BC is going to be 2.5. Let's put that in there like that. The length of the side EF is unknown, so we'll just leave that. And then the length of the side AC is 1.5. And the length of the side DF, that's unknown. Okay, so let me grab this, and we can paste this in here. Now you're just going to work on one at a time. You're going to take this guy and set it equal to this guy, and then you'll take this guy, set it equal to this guy. So let's start with 2.5 over 4 is equal to 2.5 over EF. Now, if you have the same numerator here, then obviously the denominator has to be the same for these guys to be equal, okay? But you can, again, cross multiply if you want. 4 times 2.5 would be 10, and this equals your EF, which is the length of that side EF, times this 2.5, right? Now, if I divide both sides by 2.5, we are obviously going to get that this EF, which is the length of that side EF, is equal to 10 divided by 2.5 is 4. But again, you didn't have to do all this because you could eyeball that and just see immediately that the length of that side EF is 4. So let's get rid of this. And I'm just going to come up here And for the length of the side EF, I'm just going to put that this is 4. And that should make sense because this is 2.5 and this is 4. And then this is 2.5, so this should be 4 as well, right? And you could also write this out if you're on a test. Your teacher may want you to do this, so I'll put the length of this side EF. We'll put that as equal to 4. Okay, so that's the length. Okay, let's find the length of this other guy. So we want DF now. So we have 2.5 over 4 is equal to 1.5 over DF. So let's cross multiply. So we'll have 4 times 1.5, which is 6, is equal to 2.5 times this, again, length of the side DF. If we divide both sides by 2.5, this is going to cancel. And I'm going to get that the length of the side DF is equal to 6 divided by 2.5 in your calculator. That's going to give me 2.4. So coming back up here, let's just say the length of the side DF is going to be 2.4. Let's erase this and just fill it in right there. So to answer the question, the length of the side EF is 4, and then the length of the side DF is going to be 2.4. All right, let's take a look at the practice test. For the instructions, we're told to use the given point on the terminal side of angle theta to find the value of the trigonometric function indicated. So for problem 1, we're trying to figure out what is sine of theta given this point where the x value is going to be the square root of 5 and the y value is going to be 2. So the first thing is to write out your definition for the sine of theta. So the sine of theta is given to us as y over r. So I know right now that the y value is 2. So you can just replace that and just put this as a 2 here. But I don't have my r value. If you wanted to figure out the r value, remember this is the square root of x squared plus y squared. So just plug in what you have. So this is the square root of, you'd have the square root of 5 squared plus you'd have 2 squared. So r would be equal to the square root of, the square root of 5 squared is 5, and then plus 2 squared is 4. 5 plus 4 is 9, so this is r is equal to the square root of 9, which equals 3. So now I can get rid of this r here and just replace it with the 3, and I have my sine of theta. It's just going to be 2/3. Okay, for problem 2, we want to find the cosecant of theta given this point where the x value is 2 and the y value is 2 times square root of 3. So let's say that the cosecant of theta, which I want you to remember is the reciprocal of the sine of theta. So the sine of theta is y over r. The cosecant of theta is r over y. So let's write r over y. Typically, when you write this definition, you'll say y is not allowed to be equal to 0. But here we know specifically that y is going to be 2 times the square root of 3. So we'll just plug that in. And again, we just want to figure out what is the value for r. So r is equal to the square root of x squared plus y squared. So r is equal to the square root of, you'd have 2 squared. So 2 squared plus you have this 2 times square root of 3 squared. So r is equal to the square root of, we know 2 squared is 4, then plus, this one's a little bit tricky. So again, you want to use your rule where you say that 2 would be squared, so that would give me 4. Let me write this over here, so 4. And then times the square root of 3 would be squared, so that would give me 3. So 4 times 3 would be 12, so that's what I want there. Okay, so 4 plus 12 is 16. So let's say r is the square root of 16. So then r is going to be, the square root of 16 is 4. So again, you can just replace this with a 4 here. And let me get rid of this. We're going to need the room. In this particular case, we can simplify. So 4 divided by 2 is 2. So this gives me 2 over the square root of 3. And we know from basic algebra that we don't want a square root in the denominator. So I'm going to rationalize the denominator. I'm going to multiply by the square root of 3 over the square root of 3. So this gives me 2 times the square root of 3 over 3. So this would be my cosecant of theta. Okay, for problem number 3, now we are asked to find the secant of theta given the point where the x value is 3 and the y value is negative square root of 7. We know that with the secant of theta, it's going to be the reciprocal of the cosine of theta. So the cosine of theta is x over r. With the secant of theta, it's r over x. So r over x, again, x is not allowed to be equal to 0. Here, x is going to be 3, so I'm just going to plug that in. And once again, we just need to figure out what is the r value. So if I said that r is equal to the square root of x squared plus y squared, so r is equal to the square root of, you have 3 that we're going to square. Then plus, we have this negative square root of 7 that we're going to square. So r is equal to, we know that 3 squared is 9. So this would be the square root of 9 plus. This negative being squared, you can think about that as negative 1 being squared. That's just going to be 1. So just forget about it. The square root of 7 being squared is 7. So now we have r is equal to the square root of 9 plus 7 is 16. And then r would be equal to the square root of 16, which is 4. Okay, so let's get rid of this and just put a 4 here. So the secant of theta would be 4/3. All right, for problem number 4, we want to find the cotangent of theta, given the fact that this point has an x value of negative square root of 15, and the y value is negative 7. So when we think about the cotangent of theta, remember this is the reciprocal of the tangent of theta. So the tangent of theta is y over x. The cotangent of theta is x over y. So in each case, you don't want a denominator of 0, but that's not going to come up here. So let's say that the cotangent of theta is going to be x over y. So the x value is just the negative of the square root of 15. And then the y value is just going to be negative 7. Let me make this a little bit better here. And then we know the negatives would cancel. So the final answer here for the cotangent of theta, it's going to be the square root of 15 over 7. Okay, let's look at problem 5. So we want to find the cosine of theta, given that the point here has an x value of negative 6 and a y value of negative square root of 13. So for the cosine of theta, we know that this guy is going to be x over r. Let me make this a little bit cleaner here. Okay, so for the x value, we know this is negative 6. So let me erase this and put negative 6. Again, for the r value, you just have to figure that out. Let me make this board a little bit better here. So we'll say that r is equal to the square root of x squared, so x squared, plus y squared. So r is equal to the square root of, so for x, I have negative 6. So let's put negative 6 in there. That's going to be squared. Then plus for y, I have negative square root of 13. So negative square root of 13, that's going to be squared. So r is equal to, we're going to say this is the square root of, negative 6 being squared is going to be 36. And then plus, when this negative gets squared, it's going to go away. It's just like squaring negative 1, you get 1. So the square root of 13 being squared is 13. So what you have here is 36 plus 13, which is going to be 49. So you have r is equal to the square root of 49, which equals 7. So I'll just come over here and put a 7 there. So the cosine of theta is going to be equal to negative 6/7. Okay, let's look at problem number 6 now. So we want to find the secant of theta, given that we have this point where the x value is negative 2 times square root of 5, and the y value is going to be negative 4. So for the secant of theta, this is going to be equal to the reciprocal of the cosine of theta. So the cosine of theta is x over r. With the secant of theta, it's r over x. So r over x, again, where x is not 0. But here x specifically is negative 2 times the square root of 5. Okay, for r, again, we just need to figure that out. So r is equal to the square root of x squared. So x squared plus y squared. So r is equal to the square root of, for x, I have negative 2. So negative 2 times the square root of 5, so that's going to be squared. And then plus, you have this negative 4 here for y, so that's going to be squared as well. Okay, so r is equal to, this first guy is a little bit tricky. So the negative 2 is being squared, both the negative and the 2. Okay, so if I had negative 2 being squared, this would be 4. Okay, so that's the first part of that. So you have a 4 there, then times the square root of 5 is being squared, so that's 5. So 4 times 5 would be 20. So this is r is equal to the square root of, this first part is 20, then plus negative 4 being squared is 16. So r is equal to the square root of 20 plus 16 is 36. And the square root of 36 is 6. So I can replace this r with a 6 here. And let me get rid of all this. And we'll just simplify this. So what I'm going to do is cancel a common factor of 2 between the numerator and denominator. So 6 divided by 2 is going to be 3. And so essentially you'll have negative 3 over the square root of 5. And again, we want to rationalize the denominator. So I'm going to multiply by the square root of 5 over the square root of 5. And so this equals the negative of 3 times the square root of 5 over 5. Okay, for problem number 7, again, we want to find the secant of theta, given that we have this point where the x value is 2 times square root of 3, and the y value is negative 2. So once again, for the secant of theta, it's a reciprocal of the cosine of theta. Cosine of theta is x over r. So the secant of theta is r over x, again, where x is not 0. So let me write this out, that the secant of theta is going to be r over x. And again, for the r, we're going to say this is the square root of x squared plus y squared. We know what x is, so let me plug this in. So this is 2 times the square root of 3. Then for the r value, let's just plug in. So r is equal to the square root of, you have x being squared, so you have 2 times square root of 3 being squared. So again, if you square 2, you get 4. If you square the square root of 3, you get 3. So it's just like I multiplied 4 times 3 to get 12. So I'm going to put 12 in here. Then plus, if I square the negative 2, I get 4. So here we have r is equal to the square root of 12 plus 4 is 16. And the square root of 16 is going to be 4. So I can get rid of this and just put a 4 here. Now, again, I just want to simplify. So let's get rid of this. And let's cancel a common factor of 2 between numerator and denominator. 4 divided by 2 is 2. So what this is going to give me here is 2 over the square root of 3. But again, I want to rationalize my denominator. So I'm going to multiply this by the square root of 3 over the square root of 3. So that's going to give me, we have 2 times the square root of 3 over 3. So that's going to be my secant of theta. Again, 2 times square root of 3 over 3. Okay, let's take a look at problem number 8 now. So now we want to find the cosine of theta, given that we have this point where the x value is negative square root of 13, and the y value is going to be 6. So let's just go ahead and say that the cosine of theta is going to be equal to, again, this is the x value over the r value. We already know that the x value is the negative of the square root of 13. So what's the r value going to be? Again, for the r value, it's equal to the square root of x squared plus y squared. So if I squared the negative of the square root of 13, negative 1 being squared is just 1. So this part goes away. The square root of 13 being squared is 13. So let me put 13 here. Then plus, if I square 6, I'm going to get 36. So 13 plus 36 is 49. So this is r is equal to the square root of 49, which is going to be 7. So let's put a 7 there. And that's basically it. You could put the negative out in front if you're more comfortable with that. So the cosine of theta is equal to the negative of the square root of 13 over 7. All right, for the next two problems, for the instructions, we want to find the trigonometric function values of angle theta if its terminal side is defined by the given ray. So we have this problem 9 here, where we're given negative 6x minus y is equal to 0, where x is less than or equal to 0. So for this one, you have to do a little bit more work, but it's the same as the other problems we've been working on. Essentially, you need to figure out what is the x value, what is the y value, what is the r value, and then plug into your 6 trigonometric functions. That's all you're going to do. So for this guy right here, we cannot pick an x value of 0. We talked about that in the lesson. But you can pick an x value that's less than 0. So it has to fall into this guy right here. So I'm going to choose an x value of negative 1. And whenever you do something like this, a lot of people leave comments and say, well, why did you pick negative 1? Where did you get that from? Well, I just picked something where x was less than 0. You could pick anything you want. You pick negative 5 or negative 1 trillion. Pick whatever you want. It doesn't matter. Negative 1 is easy to work with, so that's why I chose it. So then I would just plug in. So I would say negative 6 times negative 1. So I'm just plugging in for x, this negative 1 there. That's all I'm doing. So then minus y is equal to 0. So the reason I'm doing this is I'm figuring out what is the corresponding y value when x is negative 1. So negative 6 times negative 1 is 6. And you basically have minus y is equal to 0. You could add y to both sides and say that 6 is equal to y, right? Or you could flip that around and say y equals 6. So what does this mean? Well, this is an ordered pair, right? So when x is negative 1, y is 6. So you could write this as negative 1 comma 6 like this. I'm not going to do that because I don't think we need it here. But I am going to have to find my r value. And so that is the square root of x squared plus y squared. So let me write r is equal to this. X being squared, negative 1 squared is 1. Then plus y being squared, 6 squared is 36. So r here is going to be the square root of 37. So the square root of 37. So once you figure out what is x, what is y, and what is r, you just plug in to those 6 trigonometric functions that you have. So just pull out your definitions, and you say that the sine of theta is equal to y over r. We'll plug in a moment. And then we have that the cosine of theta is going to be x over r. And then we have the cosecant of theta is going to be r over y. It's the reciprocal of the sine of theta. And then we have the secant of theta, which is going to be r over x. It's the reciprocal of the cosine of theta. And then you have your tangent of theta, which is going to be y over x. And then the reciprocal of that is going to be the cotangent of theta, which is going to be x over y. Let me make this theta a little bit better. So once you have all this written out, just plug in. So for every place I see a y, I'm just going to plug in a 6. So here, and then here, and then here, and then here. Okay, that's all I have to do. Then everywhere I see an x, I'm going to plug in a -1. So that's going to be here, and also here, and here. So let's put a -1 there, a -1 there, and a -1 there. Okay, everywhere I see an r, I'm going to replace that with the square root of 37. So you have your square root of 37 here. You have your, let me erase that. So this is the square root of 37 here, and make that 3 a little bit better. And then the square root of 37 here, and then your square root of 37 here. Okay, so we're not done because there's simplifying we can do. So I'm just going to come to a fresh sheet so we have a little bit more room to work. So for this top one, the sine of theta, you need to rationalize the denominator. So I'm going to multiply by the square root of 37 over the square root of 37. So this would give me 6 times the square root of 37 over 37. So that's your sine of theta. For the cosine of theta, again, I need to rationalize the denominator. So this is times the square root of 37 over the square root of 37, which would give me, let me actually move this over just a little bit so it fits. So the negative of the square root of 37 over 37. And then down here, this one's fine as it is, the cosecant of theta. You can just leave it as the square root of 37 over 6. For the secant of theta, I would say that this is the negative of the square root of 37. And then for the tangent of theta, I would just say this is -6. For the cotangent of theta, I would leave that as -1 over 6, or you could just say negative of 1/6, whatever you want to do. All right, let's take a look at problem number 10. So here we have -4x plus 7y is equal to 0. And specifically, we're saying that x is less than or equal to 0. So again, I want to choose something for x that's not going to violate this guy right here. You cannot pick 0 and have the point 0, 0. But basically, anything else for x that does not violate this guy is good to go. So pick something where x is strictly less than 0. Let's just pick -7 for x. I think that would work out nicely. So I'm just going to say that x is equal to -7. And I need to figure out what is the corresponding y value. So -4 times -7 plus 7 times y is equal to 0. Now, the reason I picked -7 for x is because it's going to work out to be a nice integer. I know a lot of people are going to ask, well, where did you get the -7 from? Well, I just chose something where x was less than 0. That's all I did. So -4 times -7 is 28. Then plus 7y is equal to 0. Let's subtract 28 away from each side of the equation. I'll cancel this away or just erase it. And what we'll do is divide both sides of the equation by 7. So this is going to cancel, and you'll end up with y is equal to -4. Let's put this right there. Let's get rid of this. So once we know x is -7 and y is -4, we just need to figure out what is the r value. So r is equal to the square root of x squared plus y squared. So x is -7. If I square that, I get 49. And then plus y is -4. If I square that, I get 16. So 49 plus 16, that's going to be 65. So this is the square root of 65. So let's put r is equal to the square root of 65. And again, just like in the last problem, you can write everything out first and then fill things in. I think that's probably the best way to do it. So I'm going to say the sine of theta is the y over r. And then over here, let's say that the cosine of theta is x over r. And then your cosecant of theta is the reciprocal of the sine of theta. So this is r over y. And then your secant of theta is the reciprocal of cosine of theta. So it's r over x. And then your tangent of theta is y over x. And your cotangent of theta, again, it's x over y. It's just a reciprocal of this guy over here, the tangent of theta. Okay, once you've written all this out, just go through and plug in. So everywhere you see a y, just plug in a -4. So let's come through here. So -4, right there, -4, and right there, -4. Okay, so everywhere you see an x, let's plug in a -7. So this is -7, and this is -7, and this is -7. And that kind of looks like a -1, so let me fix that. And maybe I can make this one a little bit better. And then this is a -7. And then now we need to plug in for r. So r is the square root of 65. So square root of 65. And then square root of 65. And then square root of 65. And then square root of 65. And that's it. Let me grab these. And let me actually come to a fresh sheet. And my pasting goes so well here. So let me fix this. This is -4. So -4 over the square root of 65. Okay. So let me move this over just a little bit so we have some room. So I'm going to say this is equal to, again, I want to rationalize the denominator. So I'd multiply negative 4 times the square root of 65. So that's negative 4 times the square root of 65. This would be over. The square root of 65 times the square root of 65 is 65. So just rationalizing the denominator there, nothing special. This guy, you really don't need to do anything other than you can put the negative out in front. So the negative of the square root of 65 over 4. And make the 5 a little bit better. For this one, negative over negative is positive. So let's just say this is 4/7. Okay, let me slide this back over a little bit. So I have some room. And I'll say this is equal to, again, this is one where you need to rationalize the denominator. So I'm going to multiply by the square root of 65 over the square root of 65. So this is negative 7 times the square root of 65 over 65. Then this guy, again, you could just put the negative out in front. So the negative of the square root of 65, and this 65 looks terrible, so let me fix this 5. This would be over your 7. And down here, negative over negative is positive, so this is just 7/4. All right, let's take a look at the practice test. For the instructions, we want to find the values of the 5 trigonometric functions not given. So coming down here for problem number 1, we have that the tangent of theta is 2/3 and that the sine of theta is less than 0. So the first thing if you have a problem like this is to figure out in what quadrant does your angle theta lie. So what we would do is put the information together. We would start with the fact that the tangent of theta is 2/3, which is a positive value, and that the sine of theta is less than 0, which is obviously a negative value. So in the lesson, we talked about a little trick for remembering where the trigonometric functions are positive and where they're negative. So essentially, you can remember the all students take calculus. So let me set this up. In the top right of your coordinate plane, this is quadrant 1. We're going to go counterclockwise. So this quadrant over here is quadrant 2. This one down here is quadrant 3. And then this one right here is quadrant 4. Okay, so if you can just remember that you're starting at the top right and it moves counterclockwise, you'll be good to go on this. Now, I mentioned all students take calculus. Let's write that out. So all, I'm just going to put an A. Students, I'm going to put an S. Take, I'm going to put a T. And calculus, I'm going to put a C. So what this tells you is that in quadrant 1, all of the trigonometric functions are positive, okay? As you get into quadrant 2, everything is negative except for sine and cosecant. And you get that from that S, right? So you remember S is sine, and then the reciprocal of sine is cosecant. So these are both going to be positive in quadrant 2. Everything else is going to be negative. In quadrant 3, everything is negative except for the T stands for tangent, and then also the reciprocal, which is cotangent. And then in quadrant 4, everything's going to be negative except for the C stands for cosine, and then also the reciprocal, which is going to be secant. Okay, so this is how you can remember the positive or negative status for each trigonometric function. Again, it's going to be all students take calculus. Okay, so just keep repeating that. Now, in this particular example, the tangent of theta is a positive 2/3. So the tangent of theta is positive in quadrants 1 and 3. Then we're told that the sine of theta is less than 0 or negative. Well, the sine of theta is negative in quadrants 3 or 4. So putting the two pieces of information together, it's going to tell us that this guy right here, this angle theta, is going to lie in quadrant 3. So I'm going to come back up, and I'm just going to say that this is going to be our angle theta is in quadrant 3. So we're just going to write that out, and we'll remember it. Now, in terms of getting the other 5 trigonometric function values, what we'd have to do is figure out a point on the terminal side of our angle theta. Now, with the tangent of theta, by definition, this is y over x. So the mistake a lot of students make is they just say, okay, well, y must be 2 and x must be 3. But again, if you thought about that, that would be the ordered pair 3, 2, right? And where is that? That's in quadrant 1, right? So this is 3 units to the right and 2 units up. So that would be a point right there on the terminal side, but that is not consistent with the information we're given. So what's going on? Remember, if you're in quadrant 3, the x values are negative and the y values are negative, so a negative over a negative would give you a positive. So you just have to adjust this and say that, well, this would need to be a negative 3, comma, a negative 2. So in other words, a negative 3 for x and a negative 2 for y. So going 3 units to the left and then 2 units down. So right there, that would be your pointer on the terminal side. And if you wanted to draw this out, let's say this is at the origin. So let's go this right there. And then let's sketch that like that. So this would be your angle theta. Okay, so you can draw that out if you want to. As you get better at these problems, you won't need to. So this is the point we're going to use. This -3 comma -2. So coming back up here, I'm just going to put the order pair -3 comma -2. Or you could write this out and say x is equal to -3, y is equal to -2. Of course, we need our r value. And let's calculate that real quick. So the r is equal to the square root of x squared plus y squared. So -3 is your x. If you square that, you get 9. And then plus -2 is your y. If you square that, you get 4. So r here is the square root of 9 plus 4, which is the square root of 13. So the square root of 13. Okay, so once you have this information, you're actually done with this stuff. You're just going to come down and just fill in. You can write everything out first if you want. So the sine of theta is y over r. And then let's put the cosine of theta is going to be x over r. So for the next one, the reciprocal of sine is cosecant. So the cosecant of theta, this is going to be r over y. And then remember, y cannot be 0. So in all of these, the denominator can never be 0. And then for your next case, the reciprocal of the cosine is going to be secant. So let's put the secant of theta, and this is going to be r over x. Again, x can't be 0. And then we already know what tangent is. The tangent of theta, that's given to us as 2/3. And then your reciprocal for tangent is cotangent. So let's put cotangent of theta. And I'm just going to flip this, so it's going to be 3/2. So really, we just need to plug in and figure out these guys. Or you could just plug in and figure out this one, and then flip them to get these two. Okay, so it's pretty simple. So for y over r, the y value is -2. So I'm going to plug that in there. And let me just plug that in here as well. And then your r value is going to be the square root of 13. So let me put the square root of 13, and let me put the square root of 13. Now, for this one, I would just put the negative out in front, and you're done. For this one, you would rationalize the denominator. So multiply this by the square root of 13 over the square root of 13. So that's going to be -2 times the square root of 13 over 13. So let me put a 13 down here. Let me just fix this up and say this is the negative of 2 times square root of 13, and this would be over 13. Okay, so that's your answer there. So we have these three, and then I need to get these two here. We already have this one. So for x, it's going to be -3. So let me put that in there, and then also there. And then for your r, again, it's the square root of 13. So the square root of 13, and then here, the square root of 13. And again, for this one, I would just move this negative out in front. So for secant of theta, it's negative square root of 13 over 3. For the cosine of theta, you need to rationalize the denominator. So let's multiply this by the square root of 13. And then down there by the square root of 13. So this would just be 13. And again, you can move this negative out in front if you want. It's not necessary, but I like to do it. So this would be all of the 6 trigonometric function values. Your sine of theta would be negative 2 times square root of 13 over 13. Your cosecant of theta would be negative square root of 13 over 2. Your tangent of theta, which was given, is 2/3. Your cosine of theta would be the negative of 3 times square root of 13 over 13. Your secant of theta would be negative square root of 13 over 3. And your cotangent of theta is going to be 3/2. All right, let's take a look at problem number 2. So we have the secant of theta is equal to the negative of the square root of 5 over 2. And then we have the sine of theta is greater than 0, or you could say positive. Going back to our coordinate plane, if the secant of theta, which is the reciprocal of the cosine of theta, if that guy is negative, where does that happen? Well, that happens in quadrants 2 and 3. And if the sine of theta is positive, where does that happen? Well, that happens in quadrants 1 and 2. So again, putting those two pieces of information together, that tells you your angle theta is going to lie in quadrant 2. So coming back down, we would say that theta is in quadrant 2. So now that we have that piece of information, we know that the x values are going to be negative and the y values are going to be positive. Let's just write out that the secant of theta is equal to what? Remember, it's the reciprocal of the cosine of theta. The cosine of theta is x over r. So the secant of theta is r over x. Now, this guy right here is negative. So that comes from a negative over a positive or a positive over a negative. In this particular case, we know that r is going to be positive, right? So x must be negative, and that's consistent with what we have here because, again, in quadrant 2, x values are negative. So I'm just going to say that my x value here is going to be -2, and that my r value here is the square root of 5. Okay, so we have two pieces of information. Let me get rid of this. Now, I need to figure out the y value, and then I'll be good to go. I can just start plugging in. So y is equal to what? Well, to figure that out, let's plug in what we know. So we know that r is equal to the square root of x squared plus y squared. And r here is the square root of 5. Well, we know x is -2. So -2 squared would be +4. So what we could do here is just square both sides of this equation. And this would give me the square root of 5 squared is going to be 5. And this equals the square root of 4 plus y squared is going to give me 4 plus y squared. So I would just subtract 4 away from each side, cancel this away. And so we're going to have y squared is equal to 1. So let me get rid of this. And let's just write out that y squared is equal to 1. Now, from your square root property, we know that if y squared equals 1, y is equal to plus or minus the square root of 1, right? The square root of 1 is 1. So y equals plus or minus 1. Now, y is going to be +1 because in this particular case, we're in quadrant 2. So in quadrant 2, the y values are positive. We know the x values are negative. So I'm going to choose +1. So let's write everything out. We will say that the sine of theta is y over r. We'll fill this stuff in a minute. Then the cosine of theta is x over r. We know that the reciprocal of sine is going to be cosecant. So the cosecant of theta is going to be r over y. And the reciprocal of cosine is secant. So the secant of theta is going to be r over x. Now we're given this one, so we can take this one and plug it in. And then we also can just take the reciprocal of this one to get this one. We'll do that in a moment. Then we have the tangent of theta, which is y over x. And then the cotangent of theta, which is x over y. We were told that the secant of theta was the negative of the square root of 5 over 2. It's cut off right now, and I'm not going to scroll back up, but that's what it was. So the negative of the square root of 5 over 2. You can just flip this guy to get this guy. Remember, secant and cosine are going to be reciprocals. So I'm just going to erase this and put this as negative. You have 2 over the square root of 5. And go ahead and rationalize the denominator. So I'm going to multiply this by the square root of 5 over the square root of 5. So this would be the negative of 2 times the square root of 5 over 5. All right, for the other guys, for the sine of theta, let's plug in a 1 for y. And then for r, let's plug in the square root of 5. You're going to rationalize that, but before you do, just flip this guy to get this guy. Because they're reciprocals, you'd have the square root of 5 over 1, which is the square root of 5. So this guy, you'd multiply by the square root of 5 over the square root of 5. So you get the square root of 5 over 5. So this is the square root of 5 over 5, like this. And then coming down here, for y, you're going to plug in a 1. And then for x, you're going to plug in a -2. So let's just say this is -1/2. Again, the cotangent of theta, you just flip this guy. So the reciprocal of -1/2 is going to be -2. So this is -2. So the sine of theta is the square root of 5 over 5. The cosine of theta is -2 times square root of 5 over 5. The cosecant of theta is the square root of 5. The secant of theta is given to us. It was negative square root of 5 over 2. The tangent of theta is -1/2. And the cotangent of theta is -2. All right, let's take a look at problem number 3 now. So we have the tangent of theta is equal to the negative of 2 times square root of 5 over 5. And the sine of theta is less than 0. So if the tangent of theta is negative and also the sine of theta is negative, where's that going to put us? So the sine of theta is negative in quadrants 3 and 4. The tangent of theta is negative in quadrants 2 and 4. So that tells me that we're going to be in quadrant 4. So let's put that theta is in quadrant 4. Okay, so knowing that the x values are positive and the y values are negative. Okay, so we're given that the tangent of theta is equal to the negative of 2 times square root of 5 over 5. We know the tangent of theta, so the tangent of theta is y over x. In this particular case, I know that the y values have to be negative and the x values have to be positive. So let's go ahead and say that x is going to be positive 5 and that y is going to be negative 2 times square root of 5. Okay, so I just need to get my r value going. So let me scooch this over here and say that r is equal to the square root of, you have x squared plus y squared. So your x value here is 5. 5 squared is 25. And your y value here is going to be -2. So negative 2 times the square root of 5, and that's going to be squared. Let me put my square root symbol back in. So if you square negative 2, you get 4, right? And then you would multiply by the square root of 5 squared is going to be 5. So this is going to be 4 times 5, or 20. So let me put a 20 in there. So essentially you have 25 plus 20, which is 45. And 45 would break down into 9 times 5. And 9 is a perfect square. So this is 3 times square root of 5. So r is going to be 3 times square root of 5. Okay, so we have everything we need. So let's go through here and say that the sine of theta is equal to y over r. The cosine of theta is equal to x over r. The cosecant of theta is equal to r over y. The secant of theta is equal to r over x. Your tangent of theta, which is given to us as the negative of 2 times square root of 5 over 5. And then your cotangent of theta, which can be found, let me make this theta a little bit better, by just flipping this guy. So you would have the negative of 5 over 2 times square root of 5. You would rationalize the denominator there. So multiply by the square root of 5 over the square root of 5. So before you multiply here, the square root of 5 times square root of 5 would be 5. And that would cancel between numerator and denominator. So you're going to get the negative of the square root of 5 over 2. So the negative of the square root of 5 over 2. So let's go through and get the rest of these guys. So for my y, I'm going to plug in the negative of 2 times square root of 5. And then for my r, I'm going to have 3 times square root of 5. And of course, square root of 5 over square root of 5 is going to cancel. So this is just negative 2/3. So negative 2/3. You could flip this to get your cosecant of theta. So this is negative 3/2. For the cosine of theta, it's going to be x, which is 5, over r, which is 3 times square root of 5. Let's rationalize the denominator. I'm going to multiply by the square root of 5 over the square root of 5. So again, you have square root of 5 times square root of 5, which is 5. So this would be 5 down here. So 5 divided by 5 is 1. So this is square root of 5 over 3. So square root of 5 over 3. Now for this one, you could flip this. But what I did was I rationalized the denominator first before I flip this. So it makes it a little bit harder. So what I'm going to do is actually just plug in. So for the r value, again, that's 3 times square root of 5. And then for the x value, it's 5. Okay. So for the sine of theta, we have negative 2/3. For the cosine of theta, we have square root of 5 over 3. For the cosecant of theta, we have negative 3/2. For the secant of theta, we have 3 times square root of 5 over 5. For the tangent of theta, we have negative 2 times square root of 5 over 5. And then for the cotangent of theta, we have negative square root of 5 over 2. All right, let's take a look at problem number 4. So we have the cosecant of theta is equal to the square root of 17 over 4. And then the cosine of theta is greater than 0. So this is positive, and also this is positive. So going back, we think about the fact that cosecant is positive in quadrants 1 and 2, right? Cosecant is the reciprocal of sine. And then additionally, we're told that cosine is positive. Well, that's only going to be in quadrants 1 and 4. So that tells me I'm in quadrant 1. So let's put that theta is in quadrant 1. Okay, so now that we know that, the x values are positive and so are the y values. So coming down here, for the cosecant of theta, this is going to be r over y. So that tells me that r is equal to the square root of 17 and that y is equal to 4. So I just need to figure out what is x. So to do that, again, you just plug in to your r formula. So r is equal to the square root of x squared plus y squared. So we know r is the square root of 17. So let's fill that in there. And then for y, it's 4. 4 squared is 16. And then just square both sides. So I'm going to square this side and square this side. You're going to get 17 is equal to x squared plus 16. Let's go ahead and subtract 16 away from each side of the equation. So let's get rid of that from over there. So this cancels. So you're going to get x squared is equal to 1. And we'll say x squared is equal to 1. Again, from the square root property, that tells me x is equal to plus or minus 1. But essentially, you want to choose positive 1 because we're in quadrant 1. And x values and y values are both going to be positive. So I want to say x equals 1 here. So let's scooch this down and say that x is equal to 1. What I would do here is write out my sine of theta, which is going to be the reciprocal of this guy. So it's 4 over the square root of 17. But again, you have to rationalize the denominator. So let's multiply this by the square root of 17 over the square root of 17. So this is 4 times square root of 17 over 17. So 4 times square root of 17 over 17. And then you have your cosecant of theta, which is given to us. Again, this is the square root of 17 over 4. Let me slide down here. Then let me write the tangent of theta. And this is going to be y over x. Let me just fill it in now. So this is 4 over 1, which is just 4. And then let me write the cotangent of theta, which is the reciprocal of this. So this is 1/4. Okay, so all we need is the cosine of theta, which is x over r. And you need your secant of theta, which is going to be r over x. Okay, so for the cosine of theta, your x value is 1. And then your r value is going to be the square root of 17. And again, before I rationalize the denominator, let me flip this now so that I don't have to do extra work. So this is the square root of 17 over 1, which is just the square root of 17. Okay. So this guy right here, you would rationalize the denominator. You'd multiply by the square root of 17 over the square root of 17. So that's going to give you the square root of 17 over 17. So the square root of 17 over 17. Your sine of theta is 4 times square root of 17 over 17. Your cosine of theta is square root of 17 over 17. Your cosecant of theta is the square root of 17 over 4. Your secant of theta is the square root of 17. Your tangent of theta is 4. And your cotangent of theta is 1/4. All right, let's take a look at problem number 5. So we have that cotangent of theta is equal to -4/3. And then we're given that the cosine of theta is less than 0, or you could say negative. So the cotangent of theta is negative and the cosine of theta is negative. So again, coming back up here, if we think about where cotangent is negative, it's going to be negative in quadrants 2 and 4. If we think about where cosine is negative, it's going to be negative in quadrants 2 and 3. So that tells me that we're going to be in quadrant 2, right? So cosine is negative and also cotangent is negative. So let me put here that theta is in quadrant 2. Okay, so we know in quadrant 2 the x values are negative and the y values are positive. So looking at this, we are given that the cotangent of theta, so the cotangent of theta, which is x over y, is equal to -4/3. So we know that the x values are negative and the y values are positive. So that tells me that x is going to be equal to -4 and y is going to be +3. Okay. Let's get rid of this. We just need to figure out what r is. So let me slide this down here. So this r is equal to the square root of x squared plus y squared. So x here is -4. -4 squared is 16. Plus y here is 3. 3 squared is 9. 16 plus 9 is 25. So this is the square root of 25, which is going to be 5. So let's go through and write everything out. So we have the sine of theta is y over r. And then you have your cosecant of theta, which is r over y. And then you have your tangent of theta, which is y over x. But again, you can just flip the cotangent of theta. So this is just -3/4. So we already have that one. Let me make this a little bit better. And then let me write this over here. So the cotangent of theta, just so we have it, this is going to be -4/3 like this. So let's write the cosine of theta. That's going to be x over r. Let me make this theta a little bit better here. And then we have the secant of theta. That's going to be r over x. Okay, so now we'll just plug in. For the sine of theta, for y, it's 3. And for r, it's 5. And again, you can just flip this to get the cosecant of theta. So this is going to be 5/3. And then for the cosine of theta, you have an x value that's going to be -4. Let me put the negative out in front. And then the r value is 5. So this is -4/5. Again, for the secant of theta, just flip that. So it's going to be -5/4. So your sine of theta here is 3/5. Your cosine of theta here is -4/5. Your cosecant of theta is 5/3. Your secant of theta is -5/4. Your tangent of theta is -3/4. And your cotangent of theta is -4/3. All right, let's take a look at problem 6 now. So we have the tangent of theta is equal to -2/3. And then we have the cosine of theta is greater than 0 or positive. So again, if the tangent is negative, that's only going to happen in quadrants 2 and 4. And the cosine is positive, that's going to happen in quadrants 1 and 4. We know we're going to be in quadrant 4. So let me just say that theta is in quadrant 4. Okay, so that tells me that the x values are positive and the y values are negative. So if you have something like the tangent of theta is equal to -2/3 like this, well, this is y over x. And again, the y values are negative, the x values are positive. So that tells me that x is going to be +3/4. 3, and y is going to be negative 2. Okay, so we just need to figure out what is r. Let me drag this over here a little bit. And we'll say that r is the square root of x squared plus y squared. So 3 squared is going to be 9, then plus negative 2 squared is going to be 4. So 9 plus 4 is 13. So r is the square root of 13. Okay, so sliding down here, we will say that the sine of theta is going to be y over r. And again, you can just plug this in as you go, or you can write them all out. It doesn't really matter. Let's just say this is negative 2 over the square root of 13. I will come back and rationalize the denominator in a moment. Remember, we need to flip this guy, so the cosecant of theta is going to be the square root of 13 over negative 2. But let's put the negative out in front like that. Let's put our cosine of theta as x over r, so 3 over the square root of 13. Again, I'll rationalize the denominator in a moment. Then we have the secant of theta, which is going to be the square root of 13 over 3. And then we have our tangent, which is given as negative 2/3. So then the cotangent will be negative 3/2. So let's write the tangent of theta is negative 2/3. Again, that's given. And the cotangent of theta, just take the reciprocal. This is negative 3/2. All right, so for this one and this one, I'm going to rationalize the denominator. And in each case, I'm going to multiply by the square root of 13 over the square root of 13. Let me move this negative out in front. And we'll say this is 2 times square root of 13 up here, and then 13 down here. So over here, I'm just going to say 3 times square root of 13 over 13. Okay, so we have everything now. So the sine of theta is the negative of 2 times square root of 13 over 13. The cosine of theta is 3 times square root of 13 over 13. The cosecant of theta is negative square root of 13 over 2. The secant of theta is the square root of 13 over 3. The tangent of theta is going to be negative 2/3. And the cotangent of theta is negative 3/2. All right, for problem 7, we have that the secant of theta is equal to 5/4, and the sine of theta is less than 0. So the secant, which is the reciprocal of cosine, is going to be positive. So that occurs in quadrants 1 and 4. And then we're saying that the sine is negative, so that's in 3 and 4. So we'll say that our angle theta is going to lie in quadrant 4. So we'll say that theta is in quadrant number 4. Okay, so in quadrant 4, the x values are positive and the y values are negative. So coming down here, we have the secant of theta, which by definition is r over x. So this tells me that the r value here is 5, and the x value here is 4. Okay, remember, we're in quadrant 4, so x values are positive. Now, I know my y value is going to be negative. Okay, so I have to be really careful. So let's get rid of this, and let's say that, and I'm just going to put this as negative something. We would want to say that r is equal to the square root of x squared plus y squared. So r is 5. So let me plug that in there. And x is 4, so 4 squared is 16. Okay, so what you would have here is square both sides. So let me do this. So this would be squared, and this would be squared. And so this would be 25 is equal to, if I square this over here, I'm going to have y squared plus 16. Now, if I subtract 16 away from each side of this equation, I'm going to get y squared is equal to 9. When we use our square root property, you would have y is equal to plus or minus the square root of 9, which is plus or minus 3. So again, because we're in quadrant 4 and the y values are negative, you want to make sure you choose negative 3. Okay, so that's very important. So now when we set everything up, let's say that we have our sine of theta, which is going to be y over r, so negative 3/5. You have your cosecant of theta, which is the reciprocal of this, so it's negative 5/3. You have your cosine of theta, which is the reciprocal of this. So the reciprocal of 5/4 is 4/5. You have your secant of theta, which is given to us as 5/4. Then you have your tangent of theta, which is y over x. So y is negative 3 and x is 4. So this is negative 3/4. Then you have your cotangent of theta, which is the reciprocal of the tangent of theta. So this is negative 4/3. So the sine of theta is negative 3/5. The cosine of theta is 4/5. The cosecant of theta is negative 5/3. The secant of theta is 5/4. The tangent of theta is negative 3/4. And the cotangent of theta is negative 4/3. All right, let's take a look at problem number 8. So we have the secant of theta is equal to 5/4. And the sine of theta is greater than 0. So when we think about the secant of theta, again, that is the reciprocal of the cosine of theta. So that's going to be positive in quadrants 1 and 4. Then when we think about the sine of theta, that's going to be positive in quadrants 1 and 2. So basically, we know we're in quadrant 1. So let me just put here that theta is in quadrant 1. Okay, so knowing that the x values and the y values are both going to be positive, we are given that the secant of theta, so the secant of theta is 5/4. And again, the secant of theta is going to be r over x. So r here is 5. And we know that x here is 4. And we just need a y value. Okay, so let me get rid of this. We'll write that in again in a moment. So let's come down here. And let's say that we have r is equal to the square root of x squared plus y squared. And again, for r, we know that's 5. And then for x, we know that's 4. And so 4 squared would be 16. And so we just need to figure out what is y. And a lot of you can eyeball that and see that it's going to be 3 because you know that 3, 4, 5 is a Pythagorean triple. Okay, but let's just go through it for the sake of completeness. So let's just square this and let's square this. So let's say this is 25 is equal to y squared plus 16. Again, subtract 16 away from each side, and you're going to have that y squared is equal to 9. If you use your square root property, you get y is equal to plus or minus the square root of 9, which is plus or minus 3. And again, because we're in quadrant 1, we know we want a positive 3 for the y value. Okay, so going through now, we just fill everything in. And we'll say that the sine of theta is going to be y, which is 3, over r, which is 5. Let me make this 5 better here. The cosecant of theta is the reciprocal of this, so this is 5/3. Then we have our cosine of theta, which is the reciprocal of the secant of theta. So this is 4/5. We're given the secant of theta. That's just 5/4. We'll just copy that. And then for the tangent of theta, this is y over x. So it's going to be 3/4 or just 3/4. And then lastly, for the cotangent of theta, you're just going to flip this tangent of theta. So that's going to be 4/3. So the sine of theta is 3/5. The cosine of theta is 4/5. The cosecant of theta is 5/3. The secant of theta is 5/4. The tangent of theta is 3/4. And the cotangent of theta is 4/3. All right, let's take a look at problem number 9. So we have the cosecant of theta is equal to negative 13/12. And the cosine of theta is greater than 0. So if the cosecant of theta is negative and the cosine is positive, well, that's going to put us in quadrant 4. Remember, the cosecant is going to be the reciprocal of your sine. So that's going to be negative in quadrants 3 and 4. And then if you think about your cosine function, it's going to be positive in quadrants 1 and 4, right? So that puts us in terms of our angle theta in quadrant 4. So let's say that theta is in quadrant 4. So now we know the x values are positive and the y values are negative. So coming down here, we have that the cosecant of theta, which by definition is going to be r over y, this is going to be equal to negative 13/12. So for this guy here, the r value, I'm going to say it's positive 13. So positive 13. And the y value is going to be negative 12 because, again, if we're in quadrant 4, the y values are negative. So what's the x value going to be? Well, we know it's going to be a positive value. But again, you could just plug in and say that r is equal to the square root of, you have your x squared, so x squared, plus y squared. So negative 12 being squared is 144. And let me plug in a 13 for r. And before we do anything, a lot of you, again, recognize that you have a 5, 12, 13 triangle in terms of your Pythagorean triples. So a lot of you can eyeball that and say, okay, well, I know x is supposed to be positive, so it's going to be 5. So if you get good at these, you can just skip this and just go straight to the answer. But for the sake of completeness, let me just square both sides here. And this is going to give me 169 is equal to x squared plus 144. Let me get rid of this. If we subtract 144 away from each side, you're going to end up with x squared is equal to 25. And again, by the square root property, x is equal to plus or minus the square root of 25, which is plus or minus 5. And again, because the x values in quadrant 4 are positive, you want an x value of positive 5. But again, if you recognize that you have, forget about the fact that it's negative, if you have 12, 13, then you know the other guy's going to be 5 because, again, it's a Pythagorean triple. All right, for the sine of theta, I'm just going to take the reciprocal of this guy, so negative 12/13. For the cosecant of theta, that's given, so negative 13 over 12. For the cosine of theta, this is x, which is 5, over r, which is 13, so 5 over 13. For the secant of theta, we're going to flip this guy, so this is 13 over 5. Let me make this better here. Then for your tangent of theta, this is y over x, so negative 12 over 5. Let's put the negative of 12 over 5 like that. And then for the cotangent of theta, let's go ahead and flip this. So this is negative 5 over 12. Okay, so the sine of theta is negative 12 thirteenths. The cosine of theta is 5 thirteenths. The cosecant of theta is negative 13 twelfths. The secant of theta is 13 fifths. The tangent of theta is negative 12 fifths. And the cotangent of theta is negative 5 twelfths. All right, for problem number 10, we have the secant of theta is equal to 17 over 15, and we have the sine of theta is less than 0. So we see that the secant of theta is going to be positive, and the sine of theta is going to be negative. So again, the secant of theta and the cosine of theta, those guys are going to be positive in quadrants 1 and 4. Then for the sine of theta, that's going to be negative in quadrants 3 and 4. So we know our angle theta is going to be in quadrant 4. So let me put that theta is in quadrant 4. We know in quadrant 4, the x values are positive, the y values are negative. So if we're given the secant of theta is 17 over 15. Well, again, the secant of theta is r over x. So I can say that the r value is 17 and the x value is going to be 15. Now, the y value here will be negative because we are in quadrant 4. Now again, if you know your Pythagorean triples, you know that 8, 15, 17 is a Pythagorean triple. So you can immediately answer that this is negative 8 if you want to, or again, you can go through the whole thing. If you're a little bit shaky on that, then let's just go through the whole thing. So essentially you have your r is equal to the square root of x squared plus y squared. So x here is 15. 15 squared is 225. And then for r, that's 17. And then if you square both sides, essentially, let me show this so that nobody's lost. You're going to get 289 is equal to y squared plus 225. So let me get rid of this. If you subtract 225 away from each side, you're going to end up with y squared is equal to 64. And again, from the square root property, y is equal to plus or minus the square root of 64. So y equals plus or minus 8. Because we're in quadrant 4, we want a y value that's negative, so you get y is equal to negative 8. So again, if you know your Pythagorean triples, it makes your work a little bit easier in some cases. And if you're a little bit shaky on that, then you can just go through the scratch work. It's not that big of a deal. So let's come down here, and let's go ahead and say that the sine of theta is going to be y over r. So this is negative 8 over 17. So then the cosecant of theta is going to be the reciprocal of that, so negative 17 over 8. Let's say that our cosine of theta is a reciprocal of this, so 15 over 17. And then our secant of theta, which is given to us right here, is 17 over 15. Then we can say that our tangent of theta is going to be y over x. So that's negative 8 over 15. Let me make this 5 a little bit better. And then the cotangent of theta is equal to, take the reciprocal of this, so negative 15 over 8. We have the sine of theta is negative 8 over 17. The cosine of theta is 15 over 17. The cosecant of theta is negative 17 over 8. The secant of theta is 17 over 15. The tangent of theta is negative 8 over 15. And the cotangent of theta is negative 15 over 8. All right, let's take a look at the practice test. For problem number 1, we're asked to find cosine of theta and cotangent of theta, given that we have cosecant of theta is equal to negative 5 and cosine of theta is greater than 0. So we're going to be using our Pythagorean identities today. And essentially what you would do first is figure out what quadrant theta is going to lie in. And again, we talked about this over the course of the last few lessons. You use your all students take calculus. Okay, so you can review that in the previous lessons if you need to. But essentially, when you think about cosecant of theta being negative, well, the cosecant is going to be the reciprocal of sine. And sine is going to be negative in quadrants 3 and 4. So cosecant is negative in quadrants 3 and 4 as well. In terms of cosine being positive, that's going to occur in quadrants 1 and 4. So you'll look for the overlap and you say, okay, that's going to be in quadrant 4. So I'm just going to put here that theta is in quadrant 4. Okay, so just like that, that's just something we want to remember because we know the x values are going to be positive and the y values are going to be negative. So what we'll do now is use our first Pythagorean identity. So that one tells us that sine squared theta plus cosine squared theta is equal to 1. So how are we going to use this? Well, first off, we know that cosecant of theta is the reciprocal of sine of theta. So in other words, I can say that the sine of theta is equal to, just take the reciprocal of this, so it's just negative 1/5 like that. And then I can plug in a negative 1/5 here for the sine of theta. But keep in mind this is squared, and I know a lot of students get confused on this notation. This is the same thing as if I said this is sine of theta being squared like this. It's just how we write it, okay? So I'm just going to plug in a negative 1/5, and I'm going to square that here. So let me get rid of this, and I'm just going to plug in a negative 1/5 here, and I'm going to square that. So if I square negative 1/5, the negative is going to go away, and 1/5 squared is going to be 1 over 25. So this is 1 over 25 plus cosine squared theta is equal to 1. Okay, from here I want to isolate cosine squared theta on one side. So let me subtract 1 over 25 away from each side of the equation. And from here, this will cancel. So you'll have that cosine squared theta is equal to, I'm going to write this as 25 over 25 so I can have a common denominator. And we're subtracting away 1 over 25. So 25 minus 1 would be 24. So this is 24 over 25. Okay. At this point, we're going to use our square root property. So if cosine squared theta is equal to 24 over 25, then we're going to say that the cosine of theta is equal to plus or minus the square root of 24 over 25. Now, we know that the square root of 25 is 5. So let me get rid of this. Let me put this as a 5. Let me put the square root of 24 up here. And essentially, 24 is 4 times 6, and 4 is a perfect square. So the square root of 4 is 2. So let's say this is 2 times the square root of 6 like this. And so now we just have to pick if it's plus or minus. Remember, we are in quadrant 4. So we know cosine values are going to be positive in quadrant 4. So let's make this guy positive. And from there, we're pretty much good to go. This is going to be our cosine of theta. It's going to be 2 times square root of 6 over 5. Okay, so coming back up here, we have our first answer. Again, where we're told to find cosine of theta, and we have that. So now we need to figure out what is the cotangent of theta. So I'll just put a question mark for right now. So what can we use to figure this out? Well, just look through your Pythagorean identities that we talked about, and you have one where it's 1 plus the cotangent squared theta is equal to the cosecant squared theta. Well, in this case, we know that cosecant of theta is negative 5. So if I squared that, it would just be 25. So let me plug in a 25 there. I'm just going to solve for this guy right here. So let's subtract 1 away from each side of the equation. So this will cancel. You'll have cotangent squared theta is equal to 25 minus 1 is going to be 24. And then again, what I'm going to do here is use my square root property. So I'll say cotangent of theta is equal to plus or minus the square root of 24. Now we are in quadrant 4. In quadrant 4, the cotangent is going to be negative. Okay, so I'm going to take the negative square root of 24. And in this case, again, 24 is 4 times 6. 4 is a perfect square, so this is 2 times square root of 6 for this part right here. So the cotangent of theta is equal to negative 2 times square root of 6. Let me erase it from here. And we'll just come back here and say the cotangent of theta is equal to the negative of 2 times square root of 6. And again, we already found that the cosine of theta was 2 times square root of 6 over 5. All right, for problem 2, we're asked to find sine of theta and cotangent of theta, given that the tangent of theta is equal to the negative of 5 over 6, and the cosecant of theta is greater than 0. Okay, so thinking about this, if we are negative in terms of our tangent value, well, we know that we have to be in quadrants 2 or 4, because in 1 and 3, the tangent and cotangent, those guys are going to be positive. Now, we're also told here that the cosecant, which is the reciprocal of sine, this is positive. So that's true in quadrants 1 and 2, okay? So what we would see here is the overlap is in quadrant 2. So I'm going to say that theta is in quadrant 2. Okay, so the x values are going to be negative and the y values are going to be positive. We are told to find the sine of theta and the cotangent of theta. Now for the cotangent of theta, it's very easy. It's just the reciprocal of the tangent of theta. So let me write this one out first. So the cotangent of theta is equal to, you would just take the reciprocal of this. So this is the negative of 6 over 5, or you could say negative 6/5 if you wanted to. And then in terms of the sine of theta, I'm actually going to use this with my Pythagorean identity. So we have that 1 plus cotangent squared theta is going to be equal to cosecant squared theta. Remember that cosecant is the reciprocal of sine. So we can figure out what the cosecant of theta is. We can take the reciprocal and we'll have our sine of theta. So let's put equals question mark for right now. So I'm going to plug in for this. So it's cotangent squared theta. So I'm going to take this negative 6/5 and I'm going to square it. So I'm going to square this. And let's slide down a little bit. And so we'll have 1 plus the negative. If I square that, it's going to go away. 6 squared is 36 and 5 squared is 25. And this equals your cosecant squared theta. Now for this, I'd get a common denominator. So let's say this is 25 over 25. And 25 plus 36, that's going to be 61. So this is 61 over 25. So 61 over 25. I'm going to flip this around. I like what I'm solving for on the left. For most people, it doesn't matter. But I'm going to say cosecant squared theta is equal to 61 over 25. And now I'm going to use my square root property. So let's say the cosecant of theta is equal to plus or minus the square root of 61 over 25. Now, first off, we said that we are in quadrant 2. So we know that the cosecant is going to be positive in quadrant 2. So we're going to use the principal square root here. And then if I break this up, the square root of 25 is going to be 5. So this is going to be the square root of 61 over 5. Now, if I want the sine of theta, it's the reciprocal of the cosecant of theta. So the sine of theta would be equal to, I'm just going to flip this and say this is 5 over the square root of 61. You would rationalize the denominator here, so times the square root of 61 over the square root of 61. So what's going to happen is we're going to get 5 times the square root of 61 over 61. So coming back here, let's get rid of this question mark, and I'll just slide this answer in here. So we know that the cotangent of theta is negative 6/5, and the sine of theta is 5 times square root of 61 over 61. All right, for problem number 3, we're asked to find cosine of theta and tangent of theta, given that the secant of theta is equal to negative 6/5, and then the cotangent of theta is less than 0. So for the secant and the cosine, those guys are going to be reciprocals. They are positive in quadrants 1 and 4, and negative in quadrants 2 and 3. So this guy is negative, so I know I'm in quadrant 2 or 3. Now the cotangent is going to be negative or less than 0 in quadrants 2 and 4. Because remember, with cotangent or tangent, they're positive in quadrants 1 and 3. Okay, so the overlap here is going to be quadrant 2. So we'll say that theta is in quadrant 2. So now that we know that, let's think about finding the cosine of theta. So the cosine of theta, and in this case, it's just the reciprocal of the secant of theta. So just flip this. This will be negative 5/6, like that. And then additionally, we want to find the tangent of theta. So that's equal to what? Well, we're going to use a Pythagorean identity where we're going to say that the tangent squared theta then plus 1 is equal to secant squared theta. So at this point, we know that secant of theta is negative 6 over 5 or negative 6/5, however you want to say that. So I'm just going to square that. So let's square this negative 6/5. The negative is going to go away. 6 squared is 36. 5 squared is 25. So this is 36 over 25. So 36 over 25. Let's subtract 1 away from each side. So I'm just going to erase it from there to make it a little bit easier. And then if I write this with a common denominator, let's say this is 25 over 25. Well, 36 minus 25, that's going to be 11. So let's just say that this is going to be 11 over 25. So 11 over 25. And now we're going to use our square root property. So I'm going to say that this is the tangent of theta, and this is equal to plus or minus the square root of 11 over 25. Now, we said that we were in quadrant 2. In quadrant 2, the tangent of theta is going to be negative. So I want the negative square root of 11 over 25. And then for 25, it's a perfect square, right? So what I'm going to do is write this as the negative of the square root of 11 over 5. So that would be your answer for the tangent of theta. Let me get rid of all this, and let me just paste this in nicely like that. So we can see that the cosine of theta is going to be negative 5/6, and the tangent of theta is going to be equal to the negative of the square root of 11 over 5. All right, for problem number 4, we're going to find sine of theta and cosine of theta, given that cotangent of theta is 7/5, and the secant of theta is greater than 0, or you could say positive. So for the cotangent of theta, that's going to be positive in quadrants 1 and 3. For the secant of theta, that's going to be positive in quadrants 1 and 4. So we know here we're going to be in quadrant 1. So let's say that theta is in quadrant 1. Okay, so x values are positive, y values are positive. Now, let's think about how we can find the sine of theta and the cosine of theta. We're going to turn to our Pythagorean identities. And since I'm given the cotangent of theta, I'm just going to start with 1 plus the cotangent squared theta. And this is going to be equal to the cosecant squared theta. Now remember, if I find the cosecant of theta, I can take the reciprocal and I have my sine of theta. So this is one way you could do it. So coming down here, let's plug in, we'll say 1 plus, again, I'm going to take this 7/5 and plug it in for the cotangent of theta, but this is cotangent squared of theta. So what I want is 7/5 squared like this, and this equals the cosecant squared theta. Okay, let's come down here a little bit. And what I'll do is say that I have 1 plus, if you square 7, you get 49. If you square 5, you get 25. And this equals cosecant squared theta. So get a common denominator. Let's say this is 25 over 25. And so 25 plus 49, that's going to be 74. So let's say this is cosecant squared theta is equal to 74 over 25. And then from here, we can just use the square root property. And we could say that cosecant of theta is equal to plus or minus the square root of 74 over 25. Now, again, we're in quadrant 1, so we want this to be the principal square root. And essentially, this is going to be the square root of 74 over 5. So the square root of 74 over 5. And again, all I did was split this up to where it was the square root of 74 over the square root of 25. And the square root of 25 is 5. So that's how I got that down there. Now, we don't want the cosecant of theta. We want the sine of theta. We want the sine of theta, which is equal to the reciprocal of this. So it's 5 over the square root of 74. And so I'm just going to rationalize the denominator. So multiply this by the square root of 74 over the square root of 74. So this gives me 5 times the square root of 74 over 74. Okay, so let me just paste this in here. And I'm going to keep this sine of theta equals 5 over square root of 74 down here, because I'm going to use that in a moment. I'm going to get rid of this and move the simplified version over here. So that's our first answer. And then I want to find the cosine of theta. Okay, so I'm going to do that with this guy right here. So I want you to recall that sine squared theta plus cosine squared theta is equal to 1. So let's get rid of this. And I'm just going to plug that in here. Okay, so I need to square this. So I'm going to say that this is 5 over the square root of 74 being squared like this. Get rid of that. And so let's come down here a little bit. And if I square 5, I get 25. If I square the square root of 74, I get 74. Okay, so let me put plus cosine squared theta is equal to 1. So I'm going to subtract 25 over 74 away from each side of the equation. So I'm just going to erase it from over here and put minus 25 over 74 like this. And let me get a common denominator. So I'll say this is 74 over 74. Let me slide this down so it's in focus. And so 74 minus 25, that's going to be 49. So this is going to end up being cosine squared theta is equal to 49 over 74. Now again, you just use your square root property, and you'll say that the cosine of theta is equal to plus or minus the square root of 49 over 74. Now, you could break this up and say this is the square root of 49 over the square root of 74. And again, for the square root of 49, that's 7. So let me write 7 over the square root of 74 like this. We know we want the principal guy there because, again, we're in quadrant 1. Okay, so for this, all I really have to do is rationalize the denominator. So I'm going to multiply by the square root of 74 over the square root of 74. And that's going to give me a final answer of 7 times the square root of 74 over 74. So let me just paste this in and put that right there. So your sine of theta is going to be equal to 5 times square root of 74 over 74. And your cosine of theta is going to be equal to 7 times the square root of 74 over 74. All right, let's take a look at problem number 5 now. So we want to find the tangent of theta and the cosine of theta, given that the sine of theta is 1/2 and the cotangent of theta is greater than 0, or you could say positive. All right, so first and foremost, the sine of theta is positive in quadrants 1 and 2 only. Then the cotangent of theta is going to be positive in quadrants 1 and 3. So the overlap is going to be in quadrant 1. All right, so we can say that theta is in quadrant 1. So all the x values are positive and all the y values are positive. What I'm going to do is first find the cosine of theta, and then I'll use that to figure out the tangent of theta. Again, there's tons of ways you can figure this out, but that's just what I'm going to do. And we're going to start with the sine squared theta plus cosine squared theta is equal to 1. Let me put a question mark there. So at this point, we know that sine of theta is 1/2. But again, this is sine squared theta. So you're going to plug in a 1/2, but you need to square that. So this is 1/2 squared. So 1/2 squared would be 1/4. So this is 1/4. Now I would subtract that away from each side of the equation. So for simplicity, let's just erase it from here and subtract it away from over here. And I'm going to write this 1 as 4 over 4. So I have a common denominator. So then I would have 4 minus 1, which is 3, over the common denominator of 4. So now what I have is the cosine squared theta is equal to 3/4. Now I want cosine of theta. So I'm going to use my square root property and say the cosine of theta is equal to plus or minus the square root of 3/4. Now, I am in quadrant 1, so I just want the principal square root. And I can break this up into the square root of 3 over the square root of 4. We know the square root of 4 is 2, so this is the square root of 3, the square root of 3 over 2. Okay, let me make this 3 a little bit better. Let's put this right there. Okay, so we know the cosine of theta is square root of 3 over 2. We also want to figure out the tangent of theta. So we want the tangent of theta. So that equals what? Well, I can use my identity that tells me that the tangent, let me make this a better here. So the tangent of theta is equal to the sine of theta over the cosine of theta. So in this particular case, the sine of theta is 1/2, and the cosine of theta is the square root of 3 over 2. So we'll keep the 1/2 and we'll multiply by the reciprocal of this guy. So 2 over the square root of 3. And let's say that this 2 is going to cancel with this 2. And so what you're left with is 1 over the square root of 3. So let me write this right here. So 1 over the square root of 3. Let me erase this. And at this point, you just want to simplify. So you're going to rationalize the denominator and multiply by the square root of 3 over the square root of 3. So the final answer for the tangent of theta would be the square root of 3. So the square root of 3 over 3. So the cosine of theta is going to be the square root of 3 over 2. And the tangent of theta is going to be the square root of 3 over 3. All right, for problem 6, let's find the cosecant of theta and the sine of theta, given that the tangent of theta is 1/2 and the secant of theta is less than 0 or negative. So for the tangent of theta to be positive, you have to be in quadrants 1 or 3. For the secant of theta to be negative, you have to be in quadrants 2 or 3. So that tells me I'm going to be in quadrant 3 here. So let's put that theta is in quadrant 3. So the x values are negative and the y values are also negative. What we're trying to find here is the cosecant of theta and the sine of theta. Now those guys are reciprocals, so I only need to find one. So I'm given the tangent of theta is 1/2. What I'm going to use is the identity that says that 1 plus your cotangent squared theta is equal to your cosecant squared theta. We don't have cotangent, but we have tangent and cotangent are reciprocals. So what you can basically say here is that the cotangent is equal to 2 over 1 or just 2. And if I wanted to square that, I would get 4. So just plug in a 4 here. And then 1 plus 4 is 5. So basically what you have, and I'm just going to flip this around, you have the cosecant squared theta is equal to 5. So let me get rid of this. What you would do from here is use your square root property and say that the cosecant of theta is equal to plus or minus the square root of 5. Now we know that we're in quadrant 3, and in quadrant 3, the cosecant is going to be negative. So I want the negative square root of 5. Okay, so let me get rid of this. And this is what we're trying to find. So let me drag this up here. And the other guy is going to be to find the sine of theta, which is the reciprocal of this. So the negative of, let's say, 1 over the square root of 5. Let's multiply by the square root of 5 over the square root of 5. So we can rationalize the denominator. So at the end of the day, this is going to be negative square root of 5. So negative square root of 5 over 5. So this would be our answer for that. So we'll have the cosecant of theta is equal to the negative of the square root of 5, and the sine of theta is equal to the negative of the square root of 5 over 5. All right, for problem number 7, we want to find the secant of theta and the cosecant of theta, given that the sine of theta is equal to 2/3 and the cotangent of theta is greater than 0. So sine is positive, again, in quadrants 1 and 2. Cotangent is positive in quadrants 1 and 3. So this tells me that theta is in quadrant 1. So the x values and y values are both positive. Okay, so now that we know that, how are we going to find the secant of theta and the cosecant of theta? Well, the secant of theta is the reciprocal of the cosine of theta. So what I'm going to use is sine squared theta plus cosine squared theta equals 1. But let me write this as cosine squared theta is equal to 1 minus sine squared theta. So I just subtracted sine squared theta away from each side. Just make it a little bit quicker on us. This is another form. So for the sine of theta, it's 2/3. Again, we want this guy squared. So if I square 2, I get 4. And if I square 3, I get 9. Okay, so I have 1 minus 4/9. Let's write this as 9/9 like this. 9 minus 4 is 5. So this is 5/9. So this is 5/9. What you want to do is use your square root property here. So we would say that the cosine of theta is equal to plus or minus the square root of 5/9. Now again, we're in quadrant 1, so we want the principal square root. And this is going to break up into the square root of 5 over the square root of 9. And the square root of 9 is 3. So this is the square root of 5 over 3. Now, I don't want the cosine of theta. I want the secant of theta, which is the reciprocal of this. So this is going to end up being 3 over the square root of 5. So let me get rid of this. And let me say that the secant of theta is going to be 3 over the square root of 5. I would rationalize the denominator. So this is times the square root of 5 over the square root of 5. So you end up with 3 times square root of 5 over 5. So 3 times square root of 5 over 5. Now, I want my cosecant of theta, which is just the reciprocal of the sine of theta. So let me write the cosecant of theta. It's the reciprocal of this. So it's just going to be 3/2. All right, for problem number 8, we want to find cosine of theta and sine of theta, given that the cosecant of theta is equal to negative 5/3 and the tangent of theta is less than 0. So for cosecant and also for sine, remember those guys are reciprocals, they are negative in quadrants 3 and 4. For tangent and also cotangent, it's going to be negative in quadrants 2 and 4. So this tells me that I'm going to be in quadrant 4. So let's say that theta is in quadrant 4. So that means the x values are positive, the y values are negative. Okay, so thinking about this guy, how are we going to find cosine of theta and sine of theta? Well, first off, the sine of theta is just a reciprocal of the cosecant of theta. So let's say that our sine of theta is equal to, just flip this. This is the negative of 3/5. And then we also want to find the cosine of theta. So that equals what? Well, we can use our identity that says that sine squared theta plus cosine squared theta is equal to 1. And again, just like last time, I'm just going to write this as cosine squared theta is equal to 1 minus the sine squared theta like that. So it's a little bit easier. So what I want to do is just plug in for sine squared theta. So I'm plugging in a negative 3/5 and I'm squaring it. So be really careful because you have this negative sign here already. So this would throw a lot of people off. So let's go slow on this. So I'm going to plug in a negative 3/5 and I'm going to square that. Okay, so the negative is going to go away. Just like squaring negative 1, you get positive 1. 3 squared is 9, 5 squared is 25. So this is minus 9 over 25. And so I'm going to write this 1 as 25 over 25. And 25 minus 9, that's going to be 16. So this would be 16 over 25. So this is 16 over 25. So by the square root property, we can say that the cosine of theta is going to be equal to, you would take plus or minus the square root of 16 over 25. We are in quadrant 4, so cosine is positive. So let's get rid of this and just say it's the principal square root. And so the square root of 16 is 4. The square root of 25 is 5. So this is going to be 4/5. fifths like this. So let's erase this and put 4 fifths. So we would say that the sine of theta is equal to negative 3 fifths, and the cosine of theta is equal to 4 fifths. All right, for problem number 9, we want to find the sine of theta and the cosine of theta, given that the secant of theta equals negative 7/3 and the sine of theta is greater than 0 or positive. So if the secant of theta is negative, which is only going to occur in quadrants 2 and 3, and the sine of theta is positive, which is only going to occur in quadrants 1 and 2, we know that theta is in quadrant 2. So let's just put again that theta is in quadrant 2. Okay, so to figure out our sine of theta and our cosine of theta, I will start off by thinking about the fact that the cosine of theta, so the cosine of theta, is the reciprocal of the secant of theta. So I can just flip this and say it's negative 3/7. So that part's done. We need to figure out the sine of theta. So that equals what? And again, I'm just going to use the sine squared theta plus cosine squared theta equals 1. So let's write out that the sine squared theta, and I'll just put is equal to 1 minus the cosine squared theta. We know that cosine of theta is negative 3/7. So I'm going to plug in here a negative 3/7, but then I've got to remember to square it. So square the negative, it goes away. Negative 1 squared is just 1. 3 squared is 9, and 7 squared is 49. So this is going to be 9 over 49. And what I'll do here is write this 1 as 49 over 49. So I have a common denominator. And then 49 minus 9 is going to be 40. So this ends up being 40 over 49. So this is 40 over 49. Now, from the square root property, what we can do is say that the sine of theta is going to be equal to the square root of 40 over 49. Now, normally you put plus or minus, but again, we're in quadrant 2, so we know this is just the principal square root. Okay, so for this guy, I would break it up and say it's the square root of 40 over the square root of 49. We know the square root of 49 is 7, so let's say this is the square root of 40 over 7 like this. Now, the square root of 40 you can simplify because 40 is 10 times 4, and 4 is a perfect square. So the square root of 4 would be 2. So this is 2 times the square root of 10. Okay, so that's my sine of theta. Let me just write this up here. So 2 times the square root of 10 over 7. And we'll just read our answer off and say cosine of theta is equal to negative 3/7. And then the sine of theta is going to be 2 times square root of 10 over 7. All right, for problem number 10, we want to find the tangent of theta and the cotangent of theta, given that the cosine of theta is equal to negative 2/5 and the cosecant of theta is greater than 0. So for the cosine of theta, that's going to be negative in quadrants 2 and 3. For the cosecant of theta, that's going to be positive in quadrants 1 and 2. So that tells me I'm going to be in quadrant 2. So let's say that theta is in quadrant 2. And in quadrant 2, the x values are negative, the y values are positive. So we're trying to find the tangent of theta and also the cotangent of theta. So those guys are reciprocals. So I just need to find one, and then I can flip it, and I can get the other. So given that the cosine of theta is negative 2/5, let's use our identity that says that tangent squared theta plus 1 is equal to secant squared theta. Now we're going to use the fact that the secant of theta, so the secant of theta, is just going to be the reciprocal of the cosine of theta. So it's going to be negative 5/2. So I'm just going to plug that in right here. So I want negative 5/2, and just make sure we square that. Common mistake is to forget to do that. So let's get rid of that. And so I'm going to say the tangent squared theta is equal to, I'm just going to subtract 1 away from each side. So I'm going to say this is 25 over 4, just squaring it. And then again, I'm subtracting 1 away from each side. Let's say this is 4 over 4, just getting a common denominator. So 25 minus 4 is going to be 21. So this would be 21 over 4. Okay, so we have this. Let me get rid of this real quick. And I'm just going to say that the tangent of theta is equal to, again, I'm just taking the square root of each side. Over here, I need to go plus or minus. Again, from the square root property, we'll say this is plus or minus the square root of 21 over 4. Now, in quadrant 2, tangent is negative. So let's put the negative of the square root of 21 over 4. And you can break that up and say it's the negative of the square root of 21 over the square root of 4 would be 2. So this is the negative of the square root of 21 over 2. So that's your tangent of theta. If you want your cotangent of theta, you're just going to flip this. So the negative of 2 over the square root of 21, we're going to rationalize the denominator. So up here, I would multiply by the square root of 21. And then down here, I would multiply by the square root of 21. So this would just be 21 down here. Maybe we'll make this a little bit nicer. And so we would say that the tangent of theta is equal to the negative of the square root of 21 over 2. And the cotangent of theta is equal to the negative of 2 times square root of 21 over 21.